In 2016, the European Southern Observatory reported finding an exoplanet that appears to be the closest to us. Proxima b is located in the habitable zone of the star Proxima Centauri. This means that there could be life on it. And if Earth suddenly finds itself on the brink of destruction, this exoplanet could become one of the best places to move to. Moreover, flying there would take just a little more than 4 light years, which is very close by space standards. But for our current technologies, this distance is really huge. In this video, you'll discover the extent of humanity's progress in space exploration, learn about an engine capable of making a spaceship travel 600 times faster than lightning, and find out when our spacecraft might be able to reach Proxima Centauri, often referred to as the New Earth. Why is it crucial to reach Proxima b as quickly as possible? The answer lies in its location within the Centaurus constellation in the southern sky. At the knee of this constellation's front leg lies the triple star system known as Alpha Centauri. Among the stars in this system, Proxima Centauri is both the smallest and the closest to us. Currently, Proxima Centauri is moving along its vast orbit towards Earth at an impressive speed of 22 kilometers per second. This speed is 3 times faster than that of the space shuttle. Now, we have a unique and timely opportunity to explore this promising exoplanet because after the current phase of its approach, Proxima b will continue to move 700 million kilometers farther away from us each year. This distance is almost equivalent to the space between the Sun and Jupiter. If we miss this crucial window, the potential for colonization could face significant delays, possibly extending into centuries, or it might even become impossible altogether. Proxima Centauri, the star around which Proxima b orbits, is a red dwarf when compared to our Sun. It has a diameter that is 7 times smaller, is 8 times lighter, and has a temperature that is only half of our Sun's. Although it may seem relatively modest in size and brightness, settling near this star is still considered feasible. Furthermore, Proxima b is situated 20 times closer to its star than Earth is to our Sun. This close proximity could result in a situation where one side of the exoplanet is permanently facing its star, similar to the way the Moon is tidally locked with Earth. Consequently, one half of Proxima b could experience extremely high temperatures, while the other half might remain perpetually icy. However, some scientists do not view these potential challenges as insurmountable. For instance, if Proxima b has an atmosphere and oceans, these features could help to moderate the extreme temperature fluctuations between the planet's sunlit and dark sides. The presence of an atmosphere would allow for heat redistribution, potentially alleviating some of the extreme temperature differences. Additionally, Proxima b is more massive than Earth, which increases the likelihood that it could retain both air and water. This would be essential for creating a stable environment that could support life. However, there is another concern that must be addressed: the occasional violent outbursts of Proxima Centauri. As a red dwarf star, Proxima Centauri can experience dramatic increases in brightness, sometimes by a factor of 1,000. Such outbursts can lead to a significant surge in radiation that reaches Proxima b. This heightened radiation could pose a threat to any local life forms and could also affect future human colonists, potentially forcing them to seek refuge on the planet's dark side to avoid harmful radiation. Why would existing spacecraft take so long to reach Proxima b? To illustrate the enormity of this challenge, let's set aside kilometers and use our space tape measure instead. 1 astronomical unit, or AU, defines the distance from the Sun to the Earth, which is approximately 150 million kilometers. Only 5 terrestrial spacecraft have ever traveled distances that are 10 times greater than this. The New Horizons probe, which was launched in 2006, travels at a speed of 15 kilometers per second and has already conducted its mission to explore Pluto and its moons. At present, New Horizons is moving away from the Sun by about 50 astronomical units. In comparison, the twin probes Pioneer 10 and 11, which were launched by NASA in the early 1970s, have covered distances of over 120 and 100 astronomical units, respectively. The Voyager 1 and Voyager 2 probes, launched in the late 1970s, are notable for their long-distance achievements in this space marathon. Voyager 2 has traveled over 122 astronomical units, while Voyager 1 has set a record by covering more than 147 astronomical units. When we compare these achievements to the distance from Earth to Proxima b, it becomes clear just how vast this distance is and how daunting it would be for our current spacecraft to make the journey. If the most advanced Voyager 1 were to undertake a journey to Proxima b, it would confront a formidable challenge. The distance it would need to travel is 1,800 times greater than the distance it has already covered. Given Voyager 1's current speed, completing this journey would take nearly 74,000 years. To reduce this travel time, the probe would need to be equipped with additional fuel tanks to increase its velocity. However, adding these fuel tanks would significantly increase the probe's weight, leaving no space for the essential scientific instruments required for research and data collection. This added weight would thus compromise the probe's ability to conduct its mission effectively. Without the necessary scientific equipment, the primary objective of the mission, to explore and study Proxima b, would be seriously undermined. How soon can we get new engines for interstellar flights? Fortunately, scientists have been addressing the challenges associated with probe fuel for a long time. They have been experimenting with various alternative energy sources to overcome these obstacles. However, the critical question remains whether they will have enough time to develop a new fuel-powered engine before Proxima b continues to move away from Earth. Physicists Jim Woodward and Hal Fern from California are working on a promising project called the Megadrive. This concept utilizes Mach's principle, which may sound like something out of a science fiction novel, but they hope it will pave the way for interstellar space travel. The Megadrive generates vibrations and directs them using electricity and a stack of crystals. It's analogous to shaking on skates from the cold and directing that motion forward, as if using the power of a shiver to propel oneself towards a warm drink. While the idea is fascinating, its practicality depends on being highly economical. NASA has already provided funding for development, but the project is still in the theoretical stage. Without concrete progress, it's difficult to make significant advancements in space travel with this technology. British engineer Roger Scheuer took the development of space propulsion even further with his invention of the EM drive engine, which quickly earned the nickname the Impossible Drive. This engine design features a magnetron that reflects microwaves in a manner similar to a common microwave oven. The microwaves get trapped inside a cone-shaped cavity, generating a powerful thrust. The concept is eco-friendly, relying solely on electricity for its operation. However, as of now, it's not possible to determine exactly when the first working prototype will be available, which helps explain why it is called the Impossible Drive. For the task of reaching Proxima b, we require a more reliable solution. In contrast, the thermonuclear engine project is showing promising results. This engine, currently being modeled at the Princeton Plasma Physics Laboratory, would operate using the nuclear fusion energy of helium-3 and deuterium. A spacecraft equipped with such an engine could potentially reach Pluto in just 5 years, which is twice as fast as the New Horizons probe. For Proxima b, the journey would take about 42,000 years, which, although lengthy, is still a significant improvement. Unfortunately, by the time this technology could be ready, our window of opportunity to explore Proxima b may have closed. According to astronomers' projections, Proxima Centauri and its exoplanet will begin to rapidly move away from us in their orbits within 27,000 years. Currently, only one technology seems to have a chance of delivering probes there within the necessary time frame. What do spacecraft capable of quickly reaching Proxima b look like? To explore the nearest star system within the next few decades rather than thousands of years, a probe would need to accelerate to 1/5 the speed of light. This is a staggering 60,000 kilometers per second, which means traveling at a speed fast enough to circle the Earth 1.5 times every second. A truly remarkable velocity. Today, engineers are working with exceptional determination to advance the Starshot project, which aims to achieve a historic milestone in the 21st century by reaching another star for the very first time. This ambitious endeavor is driven by the desire to accomplish something monumental in the field of space exploration. As we strive toward this goal, an important question remains. What will we discover in the forthcoming images from Proxima b? Will we uncover oceans and an Earth-like atmosphere? Or will the surface reveal a scorched desert? If Proxima b turns out to be unsuitable for life, it will not signify the end of our quest. The Alpha Centauri binary system, which includes Proxima Centauri, is home to other stars with their own exoplanets. From a base on Proxima Centauri, these other planets would be within reach. Thus, we remain hopeful and confident that we will find something fascinating in the vicinity of the centrist constellation's left knee. Thank you for watching another episode of A World to Discover. If you enjoyed this video, please leave a like and feel free to subscribe. While you're still here, if the next video on your screen interests you, make sure to go and watch it. Einstein's theories of relativity have long been the cornerstone of our understanding of the universe, stating that nothing with mass can travel faster than light. But what if there's a way to bypass this cosmic speed limit? New research suggests that by warping space itself, we might be able to achieve the seemingly impossible, faster than light travel.
According to Einstein's special theory of relativity,
well, you need to take the very large and the very small together to understand the universe as a whole.
And these two tiny particles have just opened up a whole new chapter in our understanding of light, gravity, and the universe around us.
Faster than light, FTL travel has the potential to revolutionize our understanding of the universe and enable interstellar exploration. Once confined to the realm of science fiction, warp propulsion is now being taken seriously by scientists as a possible method for achieving FTL travel. This shift from fantasy to scientific consideration represents a significant leap in our approach to space exploration. The stakes are high when we consider the current limitations of space travel. Voyager 1, for instance, took 35 years just to exit our solar system. In contrast, FTL travel could open up the possibility of interstellar journeys, dramatically expanding the scope of human exploration. The implications of such technology for humanity's future in space are profound, potentially transforming our species from earthbound observers to true cosmic voyagers. Einstein's cosmic speed limit. As we contemplate our potential as cosmic voyagers, a fundamental question arises. What if the very laws of physics that seem to constrain us also hold the key to our liberation? Einstein's theories have long been considered unbreakable, but recent research suggests there might be a loophole that could redefine our understanding of space travel. At the heart of this cosmic conundrum lies Einstein's theory of relativity, which establishes a universal speed limit. This cosmic speed limit, approximately 300,000 kilometers per second, is the speed at which light travels through a vacuum. According to Einstein's equations, nothing with mass can reach, let alone exceed, this speed. The reason for this limitation is rooted in the relationship between mass and energy. As objects approach the speed of light, they gain mass, making it increasingly difficult to accelerate them further. This creates a seemingly insurmountable barrier, as it would require infinite energy to push an object with mass to light speed. This principle has far-reaching implications for space travel. Our current spacecraft, impressive as they are, fall far short of this cosmic speed limit. Even our fastest probes would take thousands of years to reach the nearest star systems. This stark reality has long been a source of frustration for scientists and space enthusiasts alike, seemingly confining humanity to our cosmic backyard. However, the story doesn't end there. In the realm of theoretical physics, a revolutionary concept is emerging that challenges our fundamental understanding of space-time itself. This new approach doesn't attempt to break Einstein's speed limit directly. Instead, it proposes a way to circumvent it entirely. The key lies in the manipulation of space-time fabric. Instead of accelerating a spacecraft to impossible speeds, this theory suggests we could warp the very space around it. Imagine a ship encased in a bubble of distorted space-time, where the fabric of space contracts in front of the vessel and expands behind it. In this scenario, the ship itself never exceeds the speed of light within its local space. Yet, from an outside perspective, it appears to move faster than light relative to distant objects. This concept, while still highly theoretical, opens up new avenues for exploration and understanding of the cosmos. It suggests that the limitations imposed by Einstein's theories may not be as absolute as previously thought. By thinking outside the conventional framework of propulsion and acceleration, we might achieve what was once considered impossible. The implications of such a breakthrough are profound. If realized, this technology could transform humanity's relationship with the universe. Interstellar travel, once the realm of science fiction, could become a reality. We could explore distant star systems, study alien worlds up close, and perhaps even establish colonies beyond our solar system. However, it's crucial to note that this concept remains firmly in the realm of theory. The challenges in making it a reality are enormous, ranging from the fundamental physics involved to the practical engineering hurdles. The energy requirements alone are staggering, far beyond our current technological capabilities. The Alcubierre drive, folding space-time. In the face of these daunting challenges, scientists have turned their attention to manipulating the medium of space itself. What if, instead of pushing against the cosmic speed limit, we could bend the rules of reality? This radical approach might just hold the answer to faster-than-light travel. Enter the Alcubierre drive, a theoretical concept proposed by Mexican physicist Miguel Alcubierre in 1994. This groundbreaking idea offers a potential solution to the seemingly insurmountable barriers of interstellar travel. The Alcubierre drive operates on a principle that sounds more like science fiction than reality: warping space-time itself. The concept is deceptively simple, yet profoundly complex. Instead of attempting to accelerate a spacecraft to impossible speeds, the Alcubierre drive proposes to create a bubble of warped space-time around the vessel. This bubble would expand space behind the spacecraft and contract it in front, effectively moving the ship through space-time without the ship itself moving within its local space. Imagine a surfer riding a wave. The surfer doesn't swim through the water, but instead rides on top of the moving wave. Similarly, a spacecraft using the Alcubierre drive would ride a wave of warped spacetime, potentially achieving faster-than-light travel relative to distant objects. One of the most intriguing aspects of this theory is its implications for the passengers of such a spacecraft. Unlike conventional propulsion methods, which subject travelers to intense acceleration forces, the Alcubierre drive offers a surprisingly comfortable journey. Within the space-time bubble, occupants would experience no felt acceleration. This means no crushing g-forces or physical stress typically associated with high-speed travel. However, the Alcubierre drive is not without its challenges. The most significant hurdle is the enormous energy requirement needed to create and sustain the warp bubble. Current estimates suggest that the energy needed would be equivalent to the mass energy of Jupiter. This staggering amount of energy presents a major barrier to the practical implementation of the theory. Another crucial component of the Alcubierre drive theory is the concept of negative mass or negative energy density. This exotic form of matter is theorized to be necessary for creating the warp bubble. However, negative matter remains purely theoretical, as it has not been discovered or proven to exist in our universe. This complicates the feasibility of the technology, adding another layer of complexity to an already challenging concept. Despite these obstacles, the Alcubierre drive theory continues to captivate scientists and space enthusiasts alike. It represents a potential loophole in our understanding of physics, offering a tantalizing possibility of faster-than-light travel without violating the principles laid out by Einstein's theories of relativity. The implications of such a breakthrough are profound. If realized, this technology could transform our relationship with the cosmos. Interstellar exploration, once confined to the realm of science fiction, could become a tangible reality. We could study distant star systems up close, explore alien worlds, and perhaps even establish colonies beyond our solar system. Recent breakthroughs, bringing warp drive closer to reality. As scientists push the boundaries of possibility, a startling question emerges. What if the key to faster-than-light travel has been hiding in plain sight all along? Recent discoveries are challenging our understanding of physics and bringing us closer to unlocking the secrets of warp drive technology. Two researchers, Dr. Eric Lentz and Dr. Harold White, have made significant strides in this field, potentially revolutionizing our approach to interstellar travel. Dr. Eric Lentz has proposed a groundbreaking new approach to warp drive that utilizes existing physical properties and positive energy densities. This innovative method stands in contrast to traditional concepts that relied on negative matter, which has yet to be discovered or proven to exist. Lentz's study describes how acceleration to the speed of light could be achieved through the manipulation of warp bubbles, using only known positive energy densities for implementation. Meanwhile, Dr. Harold White, a former NASA specialist, has made an equally exciting discovery. White identified natural warp bubbles within a Casimir cavity, a finding that could serve as a model for creating larger warp drives. This discovery suggests that these structures could potentially be mimicked on a larger scale, bringing us closer to the realization of the first true warp drive. The advancements made by Lenz and White represent a significant leap forward in warp drive technology. Their work could potentially simplify the energy requirements for warp technology, moving us closer to practical applications. This is a marked improvement over previous concepts, such as the original Alcubierre drive, which required an energy equivalent to the mass of Jupiter, an amount far beyond our current technological capabilities. One of the most promising aspects of these new approaches is their use of known physical properties and positive energy densities. This eliminates the need for exotic, theoretical materials like negative matter, which has been a major stumbling block in previous warp drive concepts. By working within the realm of known physics, these new theories bring faster-than-light travel closer to the realm of possibility. The implications of these advancements are profound. If realized, this technology could transform our relationship with the cosmos. Interstellar exploration, once confined to the realm of science fiction, could become a tangible reality. We could study distant star systems up close, explore alien worlds, and perhaps even establish colonies beyond our solar system. However, it's important to note that significant challenges remain. While these new approaches show promise, they are still theoretical and require further research and development. The energy requirements, though potentially reduced, are still substantial. Engineering such a device would require technological capabilities far beyond our current level. Despite these challenges, the work of Lenz and White represents a significant step forward in our quest for faster-than-light travel. Their research has opened up new avenues of exploration and brought us closer to understanding how we might one day traverse the vast distances of space. Beyond speed, time travel, and philosophical implications. As we stand on the precipice of interstellar exploration, an even more mind-bending possibility emerges: the potential for time travel. Could our pursuit of warp drive technology inadvertently unlock the secrets of traversing not just space, but time itself? The implications of faster-than-light, FTL, travel extend far beyond the realm of space exploration, challenging our fundamental understanding of reality and causality. The concept of FTL travel opens doors to theoretical possibilities that were once confined to the realm of science fiction. By manipulating space-time for FTL travel, we may also be creating conditions that allow for movement through time. This interconnection between space and time is a cornerstone of Einstein's theories. And as we push the boundaries of one, we inevitably affect the other. Theoretical frameworks suggest that if we can warp space to achieve FTL, we might also manipulate time in ways that could lead to time travel scenarios. These scenarios wouldn't necessarily violate the laws of physics as we understand them, but they would require us to reconsider our notions of cause and effect. The very fabric of reality as we perceive it could be altered by such capabilities. The philosophical implications of potential time travel are profound and far-reaching. One of the most well-known paradoxes associated with time travel is the grandfather paradox. This thought experiment questions the consequences of altering past events, such as preventing one's own birth. Such scenarios challenge our understanding of causality and the nature of free will. Moreover, the ability to travel through time would fundamentally change our perception of existence itself. Our current understanding of life and death, of beginnings and endings, is deeply rooted in our linear experience of time. If we could move freely through time, these concepts would need to be radically redefined. The pursuit of FTL travel and its potential time-bending consequences invite us to reconsider our place in the universe. As we contemplate the possibility of traversing vast cosmic distances in the blink of an eye, we must also grapple with the idea that our actions could have consequences across different points in time. This realization could dramatically alter our decision-making processes and our sense of responsibility to future or past generations. Furthermore, the development of FTL and time travel technologies would likely have profound impacts on various fields of study. Historians could potentially observe past events firsthand, revolutionizing our understanding of history. Scientists could verify or disprove long-held theories by directly observing phenomena across vast stretches of time. The boundaries between different scientific disciplines might blur as the interconnectedness of space, time, and matter becomes more apparent. However, it's crucial to note that these possibilities remain firmly in the realm of theory. The practical challenges of achieving FTL travel, let alone time travel, are immense. The energy requirements alone are staggering, far beyond our current technological capabilities. Additionally, the potential paradoxes and ethical dilemmas posed by time travel would need to be carefully considered and addressed before any such technology could be implemented. Despite these challenges, the exploration of FTL travel and its implications continues to push the boundaries of science and philosophy. It encourages us to question our assumptions about the nature of reality and our place within it. As we delve deeper into these concepts, we are forced to confront fundamental questions about existence, causality, and the very fabric of the universe. The road ahead, challenges and possibilities. As we push the boundaries of our understanding, we must confront a sobering reality. The energy needed for FTL travel could be equivalent to the mass of Jupiter. This astronomical requirement raises a crucial question. Are we on the brink of a breakthrough, or have we reached the limits of what's physically possible? The pursuit of faster-than-light FTL travel faces significant challenges, primarily the enormous energy requirements to warp space-time effectively. Current research suggests that the energy needed could be equivalent to the mass of Jupiter, a staggering amount that far exceeds our present technological capabilities. This energy barrier represents one of the most formidable obstacles in the quest for interstellar travel. Despite these challenges, the scientific community continues to explore innovative approaches to FTL travel. Researchers are investigating various theoretical models and attempting to refine existing concepts to reduce energy requirements and increase feasibility. However, the practical application of warp drive technology remains a considerable challenge, requiring further research to establish its technical viability. The ongoing pursuit of FTL travel is not merely a technological endeavor. It has profound implications for space exploration, scientific discovery, and the future of human civilization. Successful FTL travel could redefine humanity's place in the universe, opening up possibilities for interstellar exploration and potentially transforming our species from earthbound observers to true cosmic voyagers. Current research efforts focus on several key areas. Scientists are exploring ways to manipulate space-time more efficiently, potentially reducing the energy requirements for creating warp bubbles. Additionally, researchers are investigating alternative propulsion methods that could achieve similar results with less energy input. These efforts continue to push the boundaries of our current scientific understanding, indicating that while significant challenges remain, the quest for FTL travel is advancing. However, skepticism about FTL travel theories persists, particularly regarding the existence of negative matter. Many theoretical models for warp drives require negative matter or negative energy density to function. As of now, negative matter remains undiscovered and largely speculative, adding another layer of complexity to the development of FTL technology. The potential impact of FTL capabilities on space exploration and scientific discovery cannot be overstated. If realized, this technology could allow humans to study distant star systems up close, explore alien worlds, and perhaps even establish colonies beyond our solar system. The scientific knowledge gained from such expeditions could revolutionize our understanding of the universe and our place within it. Moreover, the development of FTL technology could have far-reaching implications for human civilization. It could lead to the establishment of interstellar trade routes, the colonization of distant planets, and the spread of human culture across the cosmos. Such advancements could fundamentally alter our perspective on resources, territory, and the very nature of human existence. Yet it's crucial to approach these possibilities with a balanced perspective. While the potential benefits of FTL travel are immense, the challenges are equally significant. The energy requirements alone present a formidable barrier, not to mention the complex engineering challenges involved in creating a functional warp drive. Additionally, the potential risks and ethical considerations of such technology must be carefully evaluated before any practical implementation. Despite these obstacles, the pursuit of FTL travel continues to captivate scientists, engineers, and dreamers alike. It represents a testament to human ingenuity and our relentless drive to explore the unknown. Even if FTL travel remains out of reach for the foreseeable future, the research conducted in its pursuit is likely to yield valuable scientific insights and technological advancements. A new frontier of discovery. The pursuit of faster-than-light travel represents a transformative shift in our understanding of the universe. It challenges long-held beliefs and prompts us to reevaluate established scientific principles. As we explore the possibilities of FTL travel, we're not just pushing the boundaries of technology, but also expanding our philosophical frameworks. The potential success of FTL travel could lead to unprecedented advancements in human understanding and exploration. It opens up the possibility of studying distant star systems and alien worlds up close, potentially enabling humanity to become true cosmic voyagers. As we contemplate this future among the stars, it's crucial to recognize that the journey towards FTL travel is both a technical and philosophical challenge. It reshapes our understanding of reality itself. While significant obstacles remain, the ongoing pursuit of FTL travel continues to inspire scientific inquiry and fuel our collective imagination about humanity's place in the cosmos. As telescopes like the James Webb peer into the Milky Way, you've likely come across the growing excitement about newly discovered exoplanets. Remarkably, it was only in 1992 that we detected the first planet outside our solar system, yet since then, more than 5,500 have been confirmed within the small region of space we occupy, stretching just a few thousand light-years. Considering the Milky Way spans 105,700 light-years in diameter, this discovery suggests the thrilling possibility of billions, if not trillions, more planets scattered throughout our galaxy. On average, each star likely has at least one planet, if not several. With all these exoplanets out there just waiting to be discovered, it's only natural that our attention would shift towards Goldilocks zones and the idea of planet habitability. After all, humanity is setting its sights on colonizing the stars, and, mathematically speaking, an Earth 2.0 is surely out there waiting for us. In fact, you've probably already encountered the term Earth 2.0 in the headlines of various articles or videos claiming that a new planet has been found that could be the perfect candidate for human life and future colonization. The excitement surrounding these discoveries fuels our imagination, making the idea of finding another Earth seem not only possible, but perhaps inevitable. However, don't believe the hype. Despite all the excitement surrounding these discoveries, the truth is that every planet we found so far has, putting it bluntly, sucked. None of them come close to being ideal for human life. In fact, once you hear the details about these planets, you'll quickly realize why moving to any of them would be the absolute last thing any sane person would ever want to do. The reality of their extreme conditions makes the idea of living there more of a nightmare than a dream. Join us today for a grand tour of the potential Earth 2.0s that have been discovered, as we explore these intriguing candidates for humanity's future home. We'll also break down why this may not be the ideal time to invest in the planetary property market just yet. When choosing an Earth 2.0, much like buying a house, it's crucial to begin by identifying your non-negotiables. Some of these factors are relatively straightforward to think about. For example, temperature. You want a comfortable, temperate climate somewhere that's neither too warm nor too cold. Since temperature decreases the farther a planet is from its star, every planetary system has a sweet spot where the temperature of a planet is likely just right, not scorching hot and not freezing cold. This idea mirrors the classic Goldilocks story, where she found her perfect bowl of porridge, neither too hot nor too cold. As a basic guideline, if a planet is located at the right distance from its star, it could very well have a suitable temperature for us to consider calling it home. Of course, this is by no means a guarantee. Venus, for example, a planet located within this zone, should theoretically be ideal for life. However, its thick, toxic atmosphere makes it the hottest planet in our solar system, even though it's farther from the Sun than Mercury. This shows that atmosphere is a crucial factor in determining a planet's habitability. When considering Earth 2.0, atmosphere is key. Ideally, you'd want one with oxygen and water vapor, and nothing that could harm us. At the very least, it should be capable of trapping heat and providing some protection from space radiation. However, an important factor to consider is the neighbors nearby. One major reason why many exoplanets in our galaxy don't meet the mark is due to the stars they orbit. Our own star, the Sun, is classified as a G-type yellow dwarf, a relatively fast-burning, short-lived type of star, especially when compared to other stars in the universe. Stars like our Sun typically live for about 10 billion years before their cores begin to collapse, eventually transforming into red giants. This stability, while short in cosmic terms, has been essential for life to flourish here on Earth. Yet yellow dwarfs like our Sun are actually quite rare in the Milky Way, making up only about 10% of the galaxy's total star population. In contrast, red dwarfs are far more common, comprising around 75% of all stars. These stars have extraordinarily long lifespans, often surviving for up to 14 trillion years, which is longer than the universe itself has existed. However, despite their longevity, planets orbiting red dwarfs face a host of challenges, as these stars come with significant drawbacks that can complicate the development of life. For starters, red dwarfs have a much closer Goldilocks zone compared to their yellow cousins. Since they burn far less brightly, with luminosities ranging from just 10% to a mere 0.0125% of our suns, the habitable zone, or Goldilocks zone, lies significantly closer to the star. This means that unless you're okay with living on a planet cloaked in what would feel like eternal night, which frankly sounds cold and pretty depressing, not to mention the difficulties it would pose for growing plants, you'd want an Earth 2.0 to orbit much nearer to its red dwarf to compensate for the lower light levels. Being closer would allow the planet to receive enough heat and light to support life, making it possible for plants and ecosystems to thrive in what might otherwise be a dim and chilly environment. This wouldn't be an issue on its own, if not for the second characteristic of red dwarfs that makes them such unpleasant neighbors: their instability. Our Sun is the primary driver of space weather, constantly sending out streams of solar winds, flares, and coronal mass ejections. These phenomena can be intense, but they pale in comparison to the space weather generated by red dwarf stars. Flares from red dwarfs can be anywhere from 100 to 1,000 times more powerful than those from our Sun. The frequent outbursts of plasma and radiation are so intense that they can strip away a planet's atmosphere and even cause any liquid water in the habitable zone to boil away. In red dwarf systems, planets are typically much closer to their star, making the odds of life developing quite slim, as the constant bombardment of deadly X-rays can wipe out any potential for life before it has a chance to arise. If humans were ever to consider living on a planet around a red dwarf, they would need far more than just some strong sun cream to survive. This rules out many exoplanets, such as the astronomers' favorite Kepler 186f, which some scientists once hoped might be habitable. While it could theoretically be possible to survive for a while in quite uncomfortable conditions, perhaps in a deep underground bunker on such a planet, the experience would be far from pleasant or sustainable in the long term. Even during calmer periods between harsh solar weather events, there's still another significant issue with planets that orbit red dwarfs: their strong tendency to become tidally locked. This means one side of the planet always faces the star, while the other remains in perpetual darkness, creating extreme conditions that make the planet even less conducive to human life. Being tidally locked means that the same side of the planet always faces its star throughout its orbit, creating a situation where one hemisphere experiences perpetual daylight while the other is locked in eternal darkness. This lack of rotation between day and night results in extreme conditions, with one side of the planet enduring relentless heat and the other plunged into freezing cold. The side facing the star could become a barren desert scorched by the constant heat, while the dark side would be perpetually frozen, covered in ice. Planets near their stars are more prone to becoming tidally locked due to gravitational forces. Mercury, for example, has incredibly long days that span 176 Earth days, or 2 Mercurian years. This absence of rotation makes it difficult for the planet to sustain life, as the temperature extremes on both sides would render much of the surface inhospitable for habitation. Even if humans attempted to survive in the narrow band of twilight that rings a tidally locked planet, the availability of liquid water would likely be a significant challenge. Any moisture present in the air that drifted toward the planet's dark side would freeze, becoming trapped as ice and essentially lost. As a result, the planet as a whole would be extremely dry, with very little chance of moisture circulating back to areas where it might be useful. Even within the twilight zone, which might offer more moderate temperatures, there would be no rainfall to replenish water supplies, making the environment harsh and unwelcoming for sustaining life. And that's not to mention the weak magnetic field likely to be found on a tidally locked planet. The dynamo effect, which powers Earth's magnetic field, is believed to be largely driven by the Coriolis effect, the planet's rotation generating momentum within the rising and falling liquid metal in its core. This movement helps sustain Earth's strong magnetic field, which shields us from solar radiation. On a tidally locked planet, where one side always faces its star and rotation is minimal or non-existent, this critical process would be significantly reduced or even absent, leading to a much weaker magnetic field and, consequently, less protection from cosmic and solar radiation. So, we're sorry to say that this rules out planets such as Proxima Centauri b, our closest exoplanet. Proxima Centauri b is otherwise an intriguing candidate. Its proximity makes it one of the most accessible planets for exploration, being situated just 4.2 light-years away from us. This distance makes it relatively close in cosmic terms, and its rocky composition adds to its appeal, especially since living on a gas giant could prove difficult for those of us who prefer solid ground beneath our feet. Even more compelling is the fact that its mass and radius closely mirror those of Earth, suggesting that its gravitational pull would be quite similar to what we experience here, potentially offering a familiar environment in terms of weight and movement. Why is this important? Let's compare it with another Earth 2.0 contender, Kepler 452b. This was the first planet to ever earn the title and was even described by a NASA scientist as the closest twin to Earth. Kepler 452b has a lot going for it. It orbits a yellow dwarf star, just like Earth, and it's at a similar distance, placing it within the so-called Goldilocks zone, where liquid water could potentially exist on its surface. However, there's a catch. It's classified as a super-Earth. This means that while it shares many similarities with our planet, its mass and radius create a gravitational force about twice as strong as Earth's. This stronger gravity could pose significant challenges for humans and other forms of life as we know them, affecting movement, growth, and overall livability despite its promising location. When it comes to gravity, how much is too much? Some scientists researching this question suggest that humans could potentially survive up to 4 times Earth's gravity, though this is considered the upper limit of what our bodies could endure. Even living in just twice Earth's gravity, however, could prove to be extremely uncomfortable and taxing. To visualize what this might feel like, imagine lying down and having a second person lie directly on top of you, pressing all of their weight against you. This would be your nightly routine, struggling for every breath under the pressure. Then, when morning comes, you would have to not only get out of bed, but lift that extra weight with you, strapping it to your back and carrying it with you throughout the day. Every step would be harder, every task more exhausting, and you'd be constantly aware of how fragile your body has become. A simple fall could easily result in broken bones, and tumbling down a flight of stairs would not just be painful, it could be deadly. Everyone would have to endure this. The elderly, struggling with frailty, the sick and infirm, already burdened by their own bodies, even small infants taking their first unsteady steps. Keeping this in mind, it's easy to grasp just how exhausting life in double gravity might end up being, as every simple movement would become a monumental effort. If you're a bodybuilder or an athlete, your well-conditioned muscles and stamina might allow you to cope better, but even then, the constant strain would take its toll. For most people on Earth, however, it would feel like a slow, unrelenting torture. Your heart would be working overtime, pounding furiously in an attempt to circulate blood efficiently, and the sheer effort of standing upright would make it feel like you're running a race, even when you're doing nothing more than staying still. And if you were to triple the gravity, it would be like carrying 2 additional people on your back at all times, and things don't get much better going the other way. Sure, Everything suddenly feels easier as the weight is lifted, but living under reduced gravity brings a whole new set of health risks. We can already see this from astronauts who've spent just a few months aboard the International Space Station. Over time, the calcium in your bones begins to bleed out, making them brittle and more prone to fractures. Your muscles weaken and atrophy as they no longer need to support your body weight. Even your heart, no longer working as hard to pump blood, can develop complications, and your immune system becomes compromised. All in all, even with a rigorous daily exercise routine, your long-term prospects in a low-gravity environment aren't promising. This harsh reality poses a significant challenge for NASA scientists as they work to figure out how to establish human outposts on the Moon or Mars, where astronauts might live for several years and face these very dangers. Humans have spent millions of years adapting to life on our planet, shaping every aspect of our biology and behavior to fit Earth's unique environment. We've become deeply accustomed to the specific conditions here, from the air we breathe to the gravity we experience and everything in between. We're just not suited to life anywhere else. Our bodies simply haven't evolved to cope with the vastly different conditions that other planets or environments would present. In some ways, this is a remarkable testament to how well we've acclimatized to the particular balance of elements, climate, and atmosphere that Earth offers. It reflects the incredible adaptability that has allowed us to thrive here. But it also presents a significant challenge if we ever hope to live beyond Earth. The very adaptations that have allowed us to flourish on our home planet become limitations when faced with the prospect of living in worlds that don't share the same characteristics. And so, the hunt for Earth 2.0 goes on. As I mentioned, there are likely billions of undiscovered planets in our Milky Way galaxy. The odds of at least one being out there that meets our criteria for gravity, temperature, lack of life-threatening radiation, and the presence of atmosphere and water are high enough to be a certainty. However, actually finding one that meets all these criteria is a much more challenging task, especially considering that most planets remain invisible to even our most powerful telescopes. We can only detect them for a brief moment when they pass in front of a convenient star and block out its light. So if someone tells you that they've already found Earth 2.0, I'd take that claim with a pinch of salt. The reality is that we won't ever truly know if a planet is suitable for human life until we somehow bridge the vast gulf of space and physically explore it ourselves. Naturally, until we figure out how to achieve that, it remains somewhat of a pointless question for now. We truly hope you enjoyed this journey through space. If you did, please show your support by liking the video and subscribing to our channel. While you're still here, feel free to click on any of the other videos on your screen and continue exploring with us.
From the outside, you can't tell what is inside a black hole.
What if everything you know about the universe is inside out? Recent theories suggest our entire cosmos could be nestled within a black hole. This mind-bending concept challenges our understanding of space and time, proposing that the very fabric of our reality might be contained within what we once thought was a cosmic destroyer.
So your feet approach the black hole faster than your head does.
Okay.
You snap into
Right.
two segments. Then each of those two segments,
Right.
eventually they snap into two segments. You
Right.
go from 1 to 2 to 4 to 8 to
Right.
16, and you're the stream of particles descending down
Now,
to
is
the
that,
abyss.
are you feeling pain or you're not?
Yeah.
And in fact, if you want to see a black hole tonight, go outside, look in the direction of Sagittarius. That's where we have the center of the galaxy, and a black hole weighing perhaps 2 to 4 million times the mass of the Sun, lurking right at the center of our own backyard.
Black holes, those mysterious cosmic entities, have long been a source of fascination for scientists and stargazers alike. These gravitational behemoths, known for their insatiable appetite for matter and light, might hold secrets beyond our wildest imaginations. But what if they're more than just cosmic vacuum cleaners? What if our entire universe exists within one? This audacious theory raises a central question. Could our entire universe be inside a black hole? It's a concept that turns our perception of reality on its head, challenging everything we thought we knew about the cosmos. As we embark on this journey of cosmic exploration, prepare for revelations that will stretch the limits of your imagination and redefine our place in the universe. Black holes, cosmic destroyers or creators. Black holes have long been viewed as the ultimate cosmic destroyers, voracious entities that consume everything in their path. This perception stems from their most defining characteristic, a gravitational pull so intense that nothing, not even light, can escape once it crosses the event horizon. But what if these cosmic giants are more than just nature's perfect vacuum cleaners? To understand the potential creative role of black holes, we must first explore their formation and nature. Black holes are born when massive stars collapse under their own gravity at the end of their lives. As the star's core implodes, it becomes incredibly dense, creating a gravitational field so strong that it warps the very fabric of space-time around it. This results in the formation of an event horizon, the point of no return beyond which nothing can escape the black hole's grasp. The immense gravitational pull of black holes is a testament to their power. Imagine a force so strong that it can bend light itself, creating a cosmic funhouse mirror effect around its edges. This gravitational lensing, as it's called, is one of the ways astronomers detect and study these elusive cosmic entities. But black holes aren't just found in isolation. In fact, they play a central role in the structure of our universe. At the heart of nearly every galaxy, including our own Milky Way, lies a supermassive black hole. These cosmic behemoths can have masses millions to billions of times that of our Sun, exerting a gravitational influence that shapes the very galaxies they inhabit. The presence of these supermassive black holes at galactic centers has led scientists to question their role in cosmic evolution. Are they merely the end result of galactic formation, or do they play an active part in shaping the universe we see today? This question challenges the traditional view of black holes as purely destructive forces. While it's true that their gravitational pull is immense, black holes are surprisingly inefficient at capturing matter from large distances. They only consume objects that venture very close to their event horizons. This selective appetite suggests that black holes might have a more nuanced role in cosmic processes than previously thought. In fact, black holes can be sources of incredible energy and cosmic phenomena. When material falls towards a black hole, it forms a swirling disk of gas and dust called an accretion disk. As this material heats up to millions of degrees, it releases enormous amounts of energy in the form of radiation. This process can create some of the brightest objects in the universe, such as quasars and active galactic nuclei. These energetic processes associated with black holes hint at their potential creative power. The radiation and jets emitted by active black holes can influence star formation and galactic evolution, shaping the cosmic landscape around them. In this light, black holes begin to look less like cosmic destroyers and more like cosmic architects, playing a crucial role in the ongoing story of our universe. The idea that black holes might be creators rather than just destroyers opens up fascinating possibilities. Could these cosmic entities be more than just the endpoint of stellar evolution? Might they, in fact, be the birthplaces of new universes? This concept challenges our understanding of the cosmos and raises intriguing questions about the nature of reality itself. If black holes can create new universes, could our own universe be nested within a larger black hole? And if so, what implications does this have for our understanding of space, time, and the fundamental laws of physics? The universe within, a new perspective. The idea that our entire universe could be nestled within a black hole is a concept that challenges our fundamental understanding of reality. This theory proposes that the cosmos we observe and inhabit might be contained within the event horizon of a massive black hole in a larger, parent universe. It's a perspective that requires us to reconsider our notions of space, time, and the very fabric of existence. To grasp this concept, imagine our universe as a bubble floating in a vast cosmic ocean. In this analogy, the surface of the bubble represents the event horizon of a black hole, and everything we know and experience exists within this bubble. The ocean surrounding it would be the larger universe or multiverse that contains our black hole universe. This theory stems from the similarities between the properties of our universe and those of black holes. Both exhibit extreme densities, intense gravitational effects, and mysterious singularities at their cores. The Big Bang, which marked the birth of our universe, shares characteristics with the formation of a black hole, suggesting a possible connection between these cosmic phenomena. One of the key principles supporting this theory is the concept of quantum gravity. This theoretical framework attempts to reconcile quantum mechanics with Einstein's theory of general relativity. In the realm of quantum gravity, the extreme conditions inside a black hole could potentially give rise to a new universe with its own set of physical laws and constants. The implications of this theory are profound. If true, it would mean that the laws of physics as we know them might only apply within our universe bubble. Beyond the event horizon of our cosmic black hole, entirely different rules could govern reality. This concept challenges our understanding of causality and the arrow of time, as events in the parent universe might influence our own in ways we cannot yet comprehend. To visualize this complex idea, consider a Russian nesting doll. Each doll represents a universe contained within a black hole of a larger universe. Our cosmos would be one of these dolls, with potentially infinite layers of reality both above and below us. This nested structure could explain the hierarchical nature of cosmic structures we observe, from subatomic particles to galactic superclusters. The black hole universe theory also offers potential explanations for some of the most perplexing mysteries in cosmology. For instance, it could account for the apparent flatness and uniformity of our universe, as the interior of a black hole would naturally create such conditions. It might also provide insights into the nature of dark energy, the mysterious force driving the accelerating expansion of the universe. Moreover, this concept aligns with the idea of cosmic inflation, the rapid expansion of the universe in its earliest moments. The intense gravitational forces at the event horizon of a black hole could produce an effect similar to cosmic inflation, explaining the uniform distribution of matter and energy we observe in our universe. However, it's crucial to note that this theory remains highly speculative. As one researcher points out, we do not understand how this central singularity works to properly understand the black hole center. This highlights the significant gaps in our knowledge regarding black holes and their implications for understanding the universe. Cosmic incubators, black holes as universe generators. As we venture deeper into the cosmic mysteries surrounding black holes, a revolutionary idea emerges. These enigmatic objects might not just be destroyers of matter, but creators of entire universes. This concept transforms our understanding of black holes from cosmic dead ends to cosmic incubators, potentially giving birth to new realms of existence. The notion of black holes as universe generators stems from the complex interplay between quantum mechanics and gravity. At the heart of this theory lies the concept of Hawking radiation, proposed by the renowned physicist Stephen Hawking. This phenomenon suggests that black holes aren't entirely black, but emit a faint glow of particles over time. Hawking radiation occurs due to quantum effects near the event horizon of a black hole. In this region, pairs of particles and antiparticles spontaneously pop into existence. Normally, these pairs would quickly annihilate each other. However, near a black hole's event horizon, one particle might fall into the black hole while the other escapes, appearing to be emitted by the black hole itself. This process has profound implications for our understanding of black holes and the universe at large. Over extremely long periods, Hawking radiation could cause black holes to slowly evaporate and shrink. This evaporation process might seem to contradict the idea of black holes as universe creators, but it's precisely this mechanism that opens up intriguing possibilities. As a black hole evaporates, it becomes smaller and denser. Some scientists propose that when a black hole reaches a critical size, the immense gravitational forces and quantum effects could trigger the formation of a new universe. This new cosmos would be born from the singularity at the center of the black hole, expanding into its own space-time separate from our own. In this scenario, black holes act as cosmic recycling machines. They consume matter and energy from one universe, only to use that material as the seeds for a new universe. This process creates a fascinating cycle of cosmic birth, death, and rebirth. The implications of this theory extend far beyond a single universe. If black holes can indeed generate new universes, it suggests the existence of a vast cosmic network. Our universe might be just one of countless others, each born from a black hole in a parent universe. This concept aligns with the idea of a multiverse, where an infinite number of universes exist simultaneously. Imagine a cosmic tree with each branch representing a universe and each leaf a black hole. These leaves might sprout new branches, creating an ever-expanding structure of interconnected realities. In this model, our universe could be a single branch on an infinitely complex cosmic tree. This theory also provides a potential explanation for the fine-tuning of our universe. The physical constants and laws that govern our cosmos seem perfectly balanced to allow for the existence of complex structures like galaxies, stars, and life. If our universe is one of many born from black holes, it's possible that each new universe inherits slightly different properties from its parent. Over time, this cosmic natural selection could result in universes increasingly capable of supporting complex structures. However, it's important to note that while these ideas are intellectually stimulating, they remain highly speculative. As one researcher points out, the surprising new insights show that there is still much to learn about black holes. Our current understanding of black holes, quantum mechanics, and the nature of the universe is still limited, and these theories push the boundaries of our knowledge. The concept of black holes as universe generators also raises fascinating philosophical questions. If our universe is indeed nested within a larger black hole, what does that mean for our understanding of reality? Are there layers of existence beyond our perception? Could the physical laws we observe be merely local phenomena with entirely different rules governing the larger multiverse? Living in a black hole, what it means for us. The idea that we might be living inside a black hole seems like something out of science fiction. Yet this theory has gained traction among some physicists, challenging our fundamental understanding of the cosmos. If true, it would revolutionize our perception of reality and our place within it. Living in a universe inside a black hole would have profound implications for our understanding of space and time. The laws of physics as we know them might only apply within our cosmic bubble, with entirely different rules governing the larger reality beyond our event horizon. This concept challenges our notions of causality and the arrow of time, suggesting that events in a parent universe could influence our own in ways we cannot yet comprehend. One of the most intriguing aspects of this theory is its potential to explain certain cosmic phenomena we observe. The apparent flatness and uniformity of our universe, for instance, could be a natural consequence of existing within a black hole. The intense gravitational forces at the event horizon could produce effects similar to cosmic inflation, accounting for the uniform distribution of matter and energy we see around us. Moreover, this theory might provide insights into the nature of dark energy, the mysterious force driving the accelerating expansion of our universe. If our cosmos is indeed nested within a black hole, the expansion we observe could be a result of our universe's growth within its host black hole. This perspective offers a fresh approach to one of the most perplexing mysteries in modern cosmology. The black hole universe theory also opens up fascinating possibilities regarding parallel universes and alternate dimensions. If our universe is one of many born from black holes, it suggests the existence of a vast cosmic network of interconnected realities. Each black hole in our universe could potentially be the birthplace of a new cosmos, creating an infinite fractal structure of nested universes. This concept aligns with the idea of a multiverse, where an infinite number of universes exist simultaneously. In this model, our universe might be just one branch on an infinitely complex cosmic tree, with each leaf representing a black hole capable of sprouting new universal realities. The implications of such a structure are mind-boggling, suggesting layers of existence beyond our current perception. However, it's crucial to acknowledge the limitations of our current understanding and technology. While these theories are intellectually stimulating, they remain highly speculative. Our knowledge of black holes, quantum mechanics, and the nature of the universe is still limited, and these concepts push the boundaries of our scientific understanding. As one researcher points out, we do not understand how this central singularity works to properly understand the black hole center. This statement underscores the significant gaps in our knowledge and the challenges we face in exploring these cosmic frontiers. Our current technology is far from being able to directly observe or test many aspects of these theories, leaving us in a realm of mathematical models and theoretical speculation. Despite these limitations, the idea of living in a universe inside a black hole offers exciting prospects for future research and exploration. It challenges us to think beyond our current paradigms and consider new possibilities for the nature of reality. This theory could potentially provide a unified framework for understanding various cosmic phenomena, from the Big Bang to the large-scale structure of the universe. If proven true, this concept would indeed revolutionize our place in the cosmos. It would suggest that our universe is part of a larger, perhaps infinite, cosmic structure. This perspective could fundamentally alter our understanding of creation, existence, and the very nature of reality itself. It raises profound philosophical questions about our significance in the grand cosmic scheme and the potential for other forms of life and civilizations existing in parallel universes. The horizon of discovery, what lies ahead? The journey to unravel the mysteries of black holes and their potential role as universe generators is far from over. Scientists are embarking on ambitious research projects and experiments to probe deeper into these cosmic enigmas. The quest to understand black holes and their implications for our universe remains one of the most exciting frontiers in modern physics. Current research focuses on several key areas. One primary goal is to detect and analyze gravitational waves produced by black hole mergers. These ripples in space-time offer valuable insights into the behavior and properties of black holes. Advanced detectors like LIGO, Laser Interferometer Gravitational Wave Observatory, and Virgo are at the forefront of this effort, capturing data from cosmic collisions billions of light years away. Another critical area of study involves observing the event horizons of black holes. The Event Horizon Telescope project, which captured the first ever image of a black hole in 2019, continues to push the boundaries of our observational capabilities. By combining data from multiple radio telescopes around the globe, scientists aim to create even sharper images of black holes and their surrounding environments. However, the path to proving or disproving the black hole universe theory is fraught with challenges. The very nature of black holes makes direct observation of their interiors impossible with current technology. The intense gravitational fields and extreme conditions near the event horizon pose significant obstacles to gathering data. Moreover, the scales involved in these theories are mind-boggling. If our universe is indeed nested within a larger black hole, the parent universe would exist on a scale far beyond our current observational limits. This raises fundamental questions about the nature of scientific inquiry and the limits of human knowledge. Despite these hurdles, scientists remain undaunted. They are developing new theoretical frameworks and mathematical models to bridge the gap between quantum mechanics and general relativity. These efforts aim to create a unified theory of quantum gravity, which could provide crucial insights into the behavior of black holes and the potential for universe generation. Technological advancements will play a crucial role in future explorations. More sensitive gravitational wave detectors, improved space-based telescopes, and in potentially even quantum computers could revolutionize our ability to study cosmic phenomena. These tools may allow us to probe deeper into the nature of black holes and test the predictions of various theoretical models. The implications of these discoveries extend far beyond the realm of physics. The concept of a black hole universe challenges our fundamental understanding of reality, space, and time. It raises profound philosophical questions about the nature of existence and our place in the cosmos. If our universe is indeed one of many nested within black holes, it suggests a vastness to reality that is difficult to comprehend. It opens up possibilities for parallel universes, alternate dimensions, and forms of existence beyond our current imagination. This perspective could reshape our understanding of creation, evolution, and the very fabric of reality. The ongoing exploration of black holes and their potential role as universe generators serves as a testament to human curiosity and ingenuity. It pushes the boundaries of our knowledge and technological capabilities, driving innovation across multiple scientific disciplines. As we continue to peer into the cosmic abyss, we are reminded of the endless possibilities that await discovery. The universe, it seems, is far more complex and mysterious than we ever imagined. Each new revelation opens up new questions, fueling the endless cycle of scientific inquiry and exploration. A universe of wonder. The black hole universe theory challenges our fundamental understanding of reality. It suggests our cosmos might be nestled within a larger black hole, part of an infinite cosmic structure. This concept offers potential explanations for mysteries like dark energy and cosmic inflation. It also raises profound questions about the nature of existence and our place in the grand scheme. While highly speculative, this theory encourages us to think beyond our current paradigms. It reminds us that the universe is far more complex and mysterious than we imagine. As we continue to explore these cosmic frontiers, we're pushed to question our assumptions and expand our understanding. Perhaps one day, as one researcher speculates, we will know exactly what lies inside of a black hole. Until then, we remain in awe of the vast, unknown cosmos that surrounds us. The night sky is poised for a dramatic change as Antares, a red supergiant 700 times larger than our sun, nears the end of its life. On the verge of a supernova, its explosion could outshine even Betelgeuse and rival the brightness of our entire galaxy. As we await this cosmic event, one question remains. What will happen when this stellar giant finally erupts?
So imagine looking on the horizon and sunrise is half the sky. Okay, that would be terrifying.
Is a supernova, first of all?
A supernova is an exploding star.
They are among the biggest explosions of radio energy in the entire universe.
Betelgeuse or Betelgeuse. It's a red giant star. If you put it where the sun is, it would extend out to the orbit of Jupiter. It's enormous. It's very unstable. It's about to explode.
Observable supernovae within our galaxy are exceedingly rare. The last recorded instance occurred centuries ago, making the potential explosion of Antares a once-in-a-lifetime spectacle. This impending celestial display offers astronomers and space enthusiasts a unique opportunity to witness cosmic history unfold before their eyes. As we embark on this journey through the cosmos, we'll explore the far-reaching impacts of this stellar explosion. From the creation of heavy elements to the potential formation of neutron stars or black holes, the aftermath of Antares supernova will shape the fabric of our galaxy for eons to come. Join us as we unravel the mysteries surrounding this cosmic ticking time bomb and its profound implications for our understanding of the universe. Antares, the red giant's final act. In the vast expanse of our night sky, one star stands out as a true celestial giant. Antares, a red supergiant located approximately 604 light-years from Earth, is a cosmic behemoth that captures the imagination of astronomers and stargazers alike. This stellar titan boasts a diameter roughly 700 times that of our sun, making it one of the largest known stars in the universe. To put its size into perspective, if Antares were placed at the center of our solar system, its surface would extend beyond the orbit of Mars. This colossal star is not only enormous, but also incredibly bright, ranking among the top 20 brightest stars visible from Earth. Its prominent position in the constellation of Scorpius makes it a familiar sight to many observers of the night sky. Antares' impressive luminosity, however, is not constant. The star's brightness fluctuates, with its apparent magnitude varying between 0.88 and 1.16. These variations, while subtle to the naked eye, are a testament to the dynamic nature of this stellar giant. As Antares pulsates and shifts, it provides astronomers with valuable data about the life cycles of massive stars. But what makes Antares truly fascinating is its current stage of life. This red supergiant is nearing the end of its stellar journey, having exhausted its primary fuel source of hydrogen. In the core of Antares, a complex dance of nuclear fusion is taking place. The star is now fusing progressively heavier elements, a process that will ultimately lead to its dramatic demise. This final act in Antares' life is a precursor to one of the most spectacular events in the universe, a supernova explosion. As the star continues to fuse heavier elements, it's building up to a cosmic crescendo that will outshine entire galaxies. When Antares finally explodes, it's expected to become so bright that it could rival the combined luminosity of every other star in the Milky Way galaxy. Imagine looking up at the night sky and seeing a single point of light as bright as our entire galaxy. This is the potential future that awaits us when Antares goes supernova. The explosion will be visible even in broad daylight, turning night into day for a brief period. It's an event that would be remembered for generations, much like the supernovae recorded by ancient astronomers centuries ago. The impending explosion of Antares offers a unique opportunity for scientific study. By observing this nearby supernova, astronomers hope to gain unprecedented insights into the death throes of massive stars. The data collected from this event could revolutionize our understanding of stellar evolution and the processes that create the heavy elements essential for life in the universe. Interestingly, the name Antares itself holds a clue to the star's appearance and historical significance. Derived from ancient Greek, the name means anti-Ares, or rival of Mars. This moniker was given because the star's reddish hue bears a striking resemblance to the red planet. Ancient astronomers noted this similarity, leading to Antares being sometimes referred to as the heart of the Scorpion in its host constellation. The connection between Antares and Mars goes beyond mere appearance. It speaks to the human tendency to find patterns and relationships in the night sky, a practice that has been central to navigation, timekeeping, and mythology for thousands of years. This celestial rivalry between Antares and Mars has been recognized by various ancient civilizations, each incorporating the star into their own cosmic narratives. The anatomy of a supernova. As we venture deeper into the mysteries of stellar evolution, we encounter one of the most awe-inspiring phenomena in the universe, the supernova. This cosmic spectacle represents the grand finale of a massive star's life, a celestial fireworks display that outshines entire galaxies. But what exactly is a supernova, and why does it captivate astronomers and casual stargazers alike? A supernova is, in essence, the largest observable explosion from Earth. It occurs when a star, having exhausted its nuclear fuel, can no longer support its own weight. The resulting collapse triggers a catastrophic explosion that releases an enormous amount of energy and light. This cosmic cataclysm is so bright that it can be seen across vast distances, sometimes even visible to the naked eye during daylight hours. The sheer scale of a supernova explosion is difficult to comprehend. During this cosmic event, material is expelled at incredible speeds, reaching several percent of the speed of light. To put this into perspective, imagine a mass several times that of our sun being ejected into space at velocities approaching 30 million miles per hour. This violent expulsion of stellar material creates shock waves that ripple through the surrounding interstellar medium, shaping the cosmic landscape for light years around. But the supernova's influence extends far beyond its immediate vicinity. These stellar explosions play a crucial role in the cosmic ecosystem, acting as factories for heavy elements. The intense heat and pressure during a supernova create conditions that forge elements heavier than iron, which are then scattered throughout space. This process enriches the interstellar medium with the building blocks necessary for the formation of new stars, planets, and even life itself. The aftermath of a supernova is equally fascinating. Depending on the initial mass of the star, the explosion can result in one of two exotic outcomes: a neutron star or a black hole. Neutron stars are incredibly dense objects, where the mass of a sun is compressed into a sphere roughly the size of a city. Their gravity is so intense that a teaspoon of neutron star material would weigh billions of tons on Earth. Black holes, on the other hand, represent an even more extreme outcome. These cosmic enigmas are regions of space where gravity is so strong that nothing, not even light, can escape. They continue to be a source of fascination for scientists and the public alike, challenging our understanding of the fundamental laws of physics. The frequency of supernovae in our galaxy adds another layer of intrigue to these cosmic events. It's estimated that between 2 to 12 stars go supernova in the Milky Way each century. Yet despite this relatively high occurrence rate, no supernova has been observed in our galaxy for several centuries. This statistical anomaly suggests that we are overdue for such an event, heightening the anticipation among astronomers for the next galactic supernova. The last recorded supernova in our galaxy was observed by Johannes Kepler in 1604, more than 4 centuries ago. Known as Kepler's supernova, it was visible to the naked eye for over a year, rivaling the brightness of the planet Mars. The long gap since this last observed event underscores the rarity of visible supernovae in our cosmic neighborhood and highlights the potential significance of Antares' eventual explosion. A celestial companion, Antares B. While Antares steals the spotlight in our cosmic narrative, it's not a solitary player in this stellar drama. Hidden in plain sight is Antares B, a lesser-known companion star that adds another layer of intrigue to this celestial system. Described as a little spark of glittering emerald, Antares B is a bluish-white star that orbits its giant red counterpart. The relationship between Antares and Antares B forms what astronomers call a binary star system. These cosmic partnerships are more common than one might think, with many stars in our galaxy existing in pairs or even larger groups. The dance between these stellar companions can have profound effects on their evolution and ultimate fate. In binary systems like Antares, the gravitational interaction between the stars can significantly influence their life cycles. This cosmic tango can alter the rate at which stars age, affect their mass loss, and even determine the nature of their eventual demise. The presence of Antares B adds an extra variable to the equation when considering the future supernova of Antares. The study of binary star systems provides astronomers with valuable insights into stellar evolution. By observing how these paired stars interact over time, scientists can refine their models of stellar life cycles and better predict the outcomes of various stellar scenarios. This knowledge is crucial for understanding not only individual stars, but also the broader cosmic processes that shape our universe. One particularly intriguing example of a binary system on the brink of a stellar explosion is T Corona Borealis. This system consists of a red giant star and a white dwarf, locked in a cosmic embrace that's about to reach a dramatic climax. Astronomers predict that T Corona Borealis will experience a nova explosion between now and September 2024, offering a rare opportunity to witness a stellar outburst in real time. A nova, while less powerful than a supernova, is still a spectacular cosmic event. In the case of T Corona Borealis, the anticipated nova is expected to be visible to the naked eye, potentially rivaling the brightness of Polaris, the North Star. This means that for a brief period, observers on Earth will be able to see what appears to be a new star blazing in the night sky. The last recorded eruption of T Corona Borealis occurred in 1946, making the upcoming event a significant astronomical occurrence. Observers can expect to see this temporary new star with the naked eye for at least a couple of days, and it will remain visible through binoculars for about a week. This provides a unique window for both professional astronomers and amateur stargazers to study and appreciate the dynamic nature of our universe. The rapid nature of nova events adds to their allure. As one researcher notes, this new star will reach its peak brightness within 24 hours of the nova explosion. This sudden burst of light serves as a stark reminder of the ever-changing nature of our cosmos, where stellar dramas unfold on timescales both impossibly long and surprisingly short. While the T Corona Borealis nova and the potential Antares supernova are different in scale, they both highlight the dynamic and sometimes explosive nature of binary star systems. These cosmic partnerships can lead to some of the most energetic events in the universe, shaping the very fabric of space around them. The cosmic ecosystem, life after supernova. In the wake of a supernova, the universe enters a phase of cosmic renewal. These stellar explosions are not merely destructive events, but rather catalysts for creation on a grand scale. Supernovae play a pivotal role in the cosmic ecosystem, acting as celestial factories that forge and distribute heavy elements throughout the universe. The process begins in the final moments of a massive star's life, As the star exhausts its nuclear fuel, it undergoes a catastrophic collapse followed by an explosive rebirth. This violent event creates conditions of extreme heat and pressure, enabling the formation of elements heavier than iron. These elements, such as gold, silver, and uranium, cannot be produced through the normal fusion processes that occur during a star's lifetime. In the midst of this cosmic crucible, these newly formed heavy elements are violently expelled into space. The explosion disperses material several times the mass of the Sun at incredible speeds, enriching the surrounding interstellar medium. This enriched material becomes the raw material for future generations of stars and planets. The elements produced in supernovae are essential for the formation of planets and life as we know it. Carbon, oxygen, and nitrogen, the building blocks of organic compounds, are among the elements scattered by these cosmic explosions. Iron, crucial for the formation of rocky planets like Earth, is also a product of supernovae. In a very real sense, we are all made of stardust, forged in the fires of ancient stellar explosions. This cosmic distribution of elements illustrates the interconnectedness of stellar and planetary evolution. The death of one star paves the way for the birth of new celestial bodies, creating a continuous cycle of cosmic renewal. It's a testament to the dynamic nature of our universe, where destruction and creation are intricately linked. Despite the crucial role supernovae play in cosmic evolution, predicting which stars will go supernova remains a significant challenge for scientists. The difficulty lies in determining the precise stages of fusion occurring within a star's core. Many stars, including red supergiants like Antares, may have millions of years left before they reach their explosive finale. The complexity of stellar evolution makes it challenging to pinpoint exactly when a star will exhaust its nuclear fuel. Factors such as mass, composition, and even interactions with companion stars can influence a star's lifespan and eventual fate. This uncertainty adds an element of cosmic suspense to the study of massive stars, as astronomers watch and wait for signs of impending stellar demise. However, the study of red supergiants like Antares provides valuable insights into the conditions that lead to supernova events. These massive stars are in a critical phase of stellar evolution, having exhausted their primary hydrogen fuel and now fusing heavier elements. By observing the behavior and characteristics of stars like Antares, astrophysicists can refine their models of stellar evolution and improve their ability to predict future supernovae. The data gathered from studying red supergiants helps scientists understand the internal processes that occur in the final stages of a massive star's life. This knowledge is crucial for developing more accurate models of stellar evolution and supernova mechanisms. As one astrophysicist noted, supernovae are indeed fascinating phenomena like no other, and they serve as a reminder of the dynamic processes that govern the universe. Each observation of a red supergiant like Antares adds to our understanding of these cosmic giants. The variations in brightness, temperature, and spectral characteristics provide clues about the internal furnaces of these stars. This information, combined with theoretical models, allows scientists to piece together the puzzle of stellar evolution and supernova prediction. The study of supernovae and their progenitor stars has far-reaching implications beyond astronomy. It touches on fundamental questions about the origin of elements, the formation of planets, and the conditions necessary for life to emerge in the universe. By understanding these cosmic processes, we gain insight into our own origins and place in the vast cosmic tapestry. Witnessing cosmic history. The universe unfolds its secrets to us in rare and spectacular events, and few are as awe-inspiring as a supernova in our own galaxy. These cosmic explosions, marking the dramatic end of a star's life, are not just visually stunning, but also scientifically invaluable. Yet, despite their significance, observing a supernova in the Milky Way is an exceptionally rare occurrence. Consider this. The last recorded supernova in our galaxy was observed over 4 centuries ago. In 1604, Johannes Kepler documented a stellar explosion that was visible to the naked eye for more than a year. This event, known as Kepler's supernova, rivaled the brightness of Mars at its peak. Since then, our galaxy has been notably quiet, at least from our earthly vantage point. The scarcity of observable supernovae in our cosmic neighborhood makes the potential explosion of Antares all the more significant. If this red supergiant were to go supernova in our lifetime, it would offer an unprecedented opportunity for scientific study and public engagement with astronomy. However, the apparent lack of supernovae in our galaxy doesn't mean these cosmic events are not occurring. Modern technology has revolutionized our ability to detect and study supernovae, even if they're not visible to the naked eye. Advanced telescopes and sophisticated detection methods allow astronomers to observe supernovae in distant galaxies, expanding our understanding of these cosmic phenomena. These technological advancements have opened new avenues for research. Astronomers can now study supernovae across vast cosmic distances, comparing data from multiple events to refine our models of stellar evolution and explosion mechanisms. This wealth of information helps scientists piece together the complex puzzle of how stars live and die. The potential future observation of Antares supernova would be a game changer in this field. Being relatively close to Earth at about 604 light-years away, Antares offers a unique opportunity for detailed study. Its explosion would provide unprecedented data on the death throes of a massive star, allowing scientists to test and refine their theories in real time. Imagine the wealth of information that could be gathered from such an event. Astronomers would be able to track the supernova's evolution from its earliest stages, observing changes in brightness, temperature, and composition as the explosion unfolds. This data would be invaluable for understanding the physical processes that drive stellar explosions and the formation of neutron stars or black holes. Moreover, the explosion of Antares would offer insights into the production and distribution of heavy elements in the universe. Supernovae are cosmic forges, creating elements heavier than iron and scattering them across space. By studying Antares supernova, scientists could gain a better understanding of how these elements are formed and dispersed, shedding light on the chemical evolution of our galaxy. The public impact of such an event would be equally significant. A supernova visible to the naked eye would capture global attention, potentially inspiring a new generation of astronomers and space enthusiasts. It would provide a rare opportunity for people worldwide to witness cosmic history firsthand, fostering a deeper appreciation for the dynamic nature of our universe. However, it's important to note that predicting when Antares will go supernova remains challenging. While the star is in the later stages of its life, it could still have thousands or even millions of years left before it explodes. This uncertainty underscores the need for continued observation and study of Antares and other potential supernova candidates. In the meantime, astronomers continue to refine their methods for detecting and studying supernova across the cosmos. Each observation, whether of a distant galaxy or a nearby star, adds to our understanding of these cosmic events and their role in shaping the universe. A new chapter in cosmic understanding. The study of Antares and supernovae opens a new chapter in our cosmic understanding. These stellar explosions not only distribute heavy elements crucial for planet formation, but also provide insights into the life cycles of massive stars. As astrophysicists refine their models, each observation of red supergiants like Antares brings us closer to predicting future supernovae. This ongoing research enhances our comprehension of the universe's dynamics and our place within it. The potential explosion of Antares represents a pivotal moment in astronomy. It offers a rare opportunity to witness cosmic history and advance our knowledge of stellar evolution. As we continue to explore the night sky, we're reminded of our deep connection to the stars. The cosmic drama unfolding above us is not just a distant spectacle, but a fundamental part of our own story. In the words of one astronomer, supernovae serve as a reminder of the dynamic processes that govern the universe.
5, 4, 3, 2, 1, 0. All engine running.
I am Buzz Aldrin.
One small step for man, one giant leap for mankind.
And I was the lunar module pilot on Apollo 11.
Space path clear. Roger.
We have a liftoff, 32 minutes past the hour. Liftoff on Apollo 11.
Buzz Aldrin, one of the few men to have walked on the moon, possesses unique insights about it thanks to his experience as a lunar astronaut. Later in life, he shared intriguing observations, hinting at mysterious entities or phenomena close enough to be observed on the moon. Does Aldrin's observations challenge conventional knowledge about the moon?
I thought it was a good idea in front of the TV to bounce around and to demonstrate how easy a guy could move around, or a gal could move around on the moon.
Is the moon not what we think it is? Let's learn more about this person. Buzz Aldrin, an astronaut renowned for his academic prowess, including a PhD from MIT, played an instrumental role in the historic Apollo 11 mission as the lunar module pilot. As the pilot of the lunar module, Aldrin had a massive job. He had to land on the moon and then make sure they could get back to Earth safely. This guy wasn't just very intelligent. He was also a top fighter pilot in the Korean War. His mix of brainpower and flying skills was key to the mission's success. But there's more. We're also looking at how Aldrin kept his cool under pressure. Imagine this: you're descending to the moon and you're hit with computer alarms, unknown boulders on the surface, and your fuel's running low. Sounds scary, right? Well, Aldrin, alongside Neil Armstrong, handled it like a pro. His ability to stay calm and make quick, smart decisions was crucial, especially during those tense moments. Thanks to him, the Eagle landed safely on the moon. Stay tuned as we explore the amazing journey of Buzz Aldrin on Apollo 11. The historic moon landing. Guess what? Buzz Aldrin was the second guy to walk on the moon, right after Neil Armstrong. When he stepped onto the moon, he didn't just make history, he became a part of it. But walking on the moon was just one part of his mission. Aldrin was super busy up there, setting up all sorts of science experiments. These weren't just any experiments. They were designed to help us learn everything about the moon, like what it's made of and what its surface is like. Thanks to him, we know a lot more about the moon now. Aldrin also did something really important. He planted the American flag there. This wasn't just about being patriotic. It was a big moment showing what humans can achieve when we aim for the stars. And there's the special thing he did that not many people know about. While he was on the moon, Aldrin took some time for a personal spiritual moment. He actually took communion. It's a reminder that behind all the science and exploration, there's a human touch. Let's talk about how Aldrin described the moon. He called it magnificent desolation. What a way to describe it. It's like he was saying the moon is incredibly beautiful, but also really empty and quiet. It must have been such an unreal experience to stand there in this huge, silent place, so far from Earth. Space sickness experience. Let's dive into something that is about Buzz Aldrin that is not talked about much. His experience with space sickness during the Apollo 11 mission. You know, being an astronaut is not just about the cool stuff like floating in zero gravity or walking on the moon. There are some tough challenges too, and space sickness is definitely one of them. You can compare it with seasickness if you have ever had it before. Now, when Aldrin was up there in space, he actually got really sick. But here's the thing. Back then, nobody really talked about it. It wasn't until later, in his autobiography and some interviews, that Aldrin opened up about this experience. This was a big deal because it showed a side of astronauts we don't often see, their human, vulnerable side. Space sickness, or what they call motion sickness in space, can be pretty rough. Imagine feeling dizzy, nauseous, and just all around terrible while you're trying to do your job millions of miles away from Earth. It's not fun. Aldrin dealing with this while on such an important mission just shows how tough and resilient astronauts have to be. But why is this important? Well, it reminds us that astronauts are people too. They face challenges and have to overcome them just like the rest of us. Aldrin sharing his story of space sickness helps us understand and appreciate the real, human side of space exploration. It's not always smooth sailing or smooth flying in this case. Theories on extraterrestrial life and moon's far side. Now let's talk about something that's really out of this world. Buzz Aldrin has dropped some hints that have got everyone talking. He suggested that there might be hidden structures or even bases on the far side of the moon. This could mean something huge, like ancient civilizations or extraterrestrial activity. This idea isn't just some sci-fi fantasy. It's coming from a man who's actually walked on the moon. So when Aldrin talks about these possibilities, people listen. His comments have sparked a ton of interest and loads of speculation, not just among space enthusiasts, but even in the scientific community. Now think about it. The far side of the moon is this mysterious place that we've never seen from Earth. So when someone like Aldrin hints at something hidden over there, it's no wonder everyone's imagination goes into hyperdrive. Could there be structures we've never seen before? Signs of ancient moon visitors? Maybe even evidence of aliens? These ideas have sent people rushing to look at lunar images and data, searching for any clues that might support Aldrin's suggestions. But here's the thing. While some people claim they found evidence of weird structures or unnatural formations on the moon, a lot of it could be our brains playing tricks on us, seeing patterns that aren't really there. That said, the fact that a seasoned astronaut like Aldrin even entertains these ideas adds a serious dose of intrigue to the whole discussion. Observation of a mysterious object in space. During the historic Apollo 11 mission, Aldrin reported something extraordinary. He observed an object in space that he couldn't identify. This wasn't just a piece of their spacecraft or some random space junk. It was something different, something that even a seasoned astronaut like Aldrin couldn't recognize. Now, imagine this. You're thousands of miles away from Earth in the vast emptiness of space, and you see something mysterious floating out there. That's exactly what happened to Aldrin. This wasn't a quick glimpse either. He saw an object that seemed to move in a controlled way, not just tumbling through space like debris. This sighting was unusual enough to catch the attention of the entire crew. This sighting sparked a lot of conversations and theories, especially about the possibility of extraterrestrial life. It's one of those incidents that make you wonder what's really out there. Was it an optical illusion, a reflection, or something more? Some space enthusiasts even dared to ask if it could be evidence of intelligent life, taking an interest in humanity's first journey to the moon. Aldrin has been open about this experience, discussing it in interviews and being transparent about what he saw and felt. He didn't jump to any wild conclusions, but he also didn't dismiss what he saw as nothing. This account from Apollo 11 adds a layer of mystery and excitement to the mission's story. Belief in extraterrestrial life. Aldrin has some other fascinating thoughts about life beyond Earth. Think about it. The universe is incredibly huge, with billions of galaxies, each filled with billions of stars. Around those stars orbit countless planets. Aldrin thinks that in all that immense space, it's almost more unlikely that Earth is the only place with life. He's not just dreaming big. He's basing his ideas on the probabilities given the size of the cosmos. But Aldrin doesn't stop at just believing there's life out there. He's a big advocate for continuing to explore space, to push further into the unknown. Why? Because he thinks that by exploring, we might actually find other life forms. Imagine the breakthroughs and the leaps in understanding we could achieve if we encountered life beyond Earth. Aldrin's perspective is really a call to action for humanity. He's urging us to keep exploring space, not just to satisfy our curiosity, but also to connect with potential life out there. This isn't just about launching rockets and satellites. It's about a deeper understanding of our place in the universe. Life on the moon, possibilities and challenges. Now, when we think of the moon, we usually picture this barren, desolate landscape with extreme conditions. It's a place with no atmosphere, extreme temperature swings, and bombarded by cosmic rays and solar winds. Not exactly the kind of spot you'd think life would call home, right? But there's more to this story. It's this wild idea that life can actually hitch a ride across the cosmos, potentially even reaching the moon. This could happen through asteroids, comets, or even interstellar dust. Imagine tiny life forms or organic materials getting a lift from Earth or other planets and ending up on the moon. But that's not the only way life could make it to the moon. Human activity could also play a part. We've been sending spacecraft and landers to the moon since the 1950s. Now, what if some of these missions accidentally carried microscopic stowaways? It's entirely possible. In 2019, an Israeli spacecraft called Bereshit crashed on the moon. But it wasn't alone. It had a payload that included thousands of tardigrades. If you don't know what tardigrades are, they're these tiny, tough animals that can survive extreme conditions. We're talking about surviving in space. So there's a chance these little guys could be living it up on the moon right now. Now, we're not saying there's a thriving ecosystem up there. If there's any life on the moon, it's probably super simple, like bacteria or fungi, and it would have to be in very isolated spots, like inside rocks or in ice at the poles. While it's unlikely that the moon has its own native life forms, the idea that life could hitch a ride that isn't so far-fetched. It's these kinds of possibilities that make space exploration so exciting. We're constantly learning and re-evaluating our understanding of life in the cosmos. What do you think? Do you believe in Buzz Aldrin's observations? Could it possibly be any life beyond our planet, or even on our neighbor the moon? Let us know your thoughts in the comments below. We hope you found these facts intriguing. If you heard them before or have any thoughts to share, please let us know in the comments below. Don't forget to give us a thumbs up and subscribe to A World to Discover to join us on our journey of discovery.
For over a century since Einstein first predicted their existence in 1916, the scientific community and enthusiasts alike have been captivated by the allure of capturing an actual photograph of a black hole. These cosmic giants, powerful beyond comprehension yet invisible to the naked eye, stir both awe and mystery in our quest for understanding the universe. As we explore these massive beasts of the cosmos, we delve into how something so immensely powerful can remain virtually unseen, hidden within the very fabric of space-time itself. Join us as we uncover the secrets of these mysterious phenomena.
Now we've got it in the bag. We've actually photographed the silhouette, the shadow of a black hole. But that's just the
historical context and theoretical foundations. Albert Einstein's groundbreaking theory of general relativity in 1916 revolutionized our understanding of gravity and the cosmos, predicting phenomena that even he could barely imagine, including black holes. These theoretical voids in the fabric of space-time, where gravity's pull is so strong that nothing, not even light, can escape, remained a mathematical curiosity for decades. It wasn't until the 1960s that black holes shifted from theoretical constructs to observable realities. Astronomers studying the Cygnus constellation observed a blue star emitting unusual X-rays and behaving erratically around an invisible partner. This led to the discovery of Cygnus X1, a compelling candidate for a black hole, providing the first physical evidence that these cosmic behemoths were not just theoretical fantasies, but real astronomical entities in our universe. First discovery and characteristics of black holes. The story of black holes took a dramatic turn with the discovery of Cygnus X1. In the 1960s, astronomers studying the Cygnus constellation were intrigued by an unusually bright blue star emitting X-rays at an extraordinary rate. This was no ordinary celestial body. It was a stellar phenomenon behaving in ways that defied initial understanding. Further investigation revealed that these X-rays were not just emanating on their own, but were being intensely pulled into a nearby invisible object, which we now know as a black hole. This discovery was pivotal because it provided the first concrete evidence of black holes' existence, confirming Albert Einstein's theoretical predictions. Cygnus X1 exhibited properties that were both fascinating and terrifying. It shone with a luminosity about 14 times that of our Sun, yet its gravitational pull was so strong that not even light could escape it, rendering the black hole invisible and justifying its name. This immense gravitational force is crucial for understanding why black holes are such a significant find in the cosmos. They are not merely vacuums in space, but regions where gravity reshapes the very fabric of reality. This blend of visible indicators and invisible forces made Cygnus X1 a landmark in astronomical studies and sparked a renewed interest in probing deeper into the nature of black holes, research evolution, and modern understanding. Over the decades, our understanding of black holes has transformed dramatically. From theoretical predictions to tangible evidence, the journey culminated in a groundbreaking moment in 2021 when scientists captured the first clear photograph of a black hole located in the M87 galaxy. This image wasn't just a snapshot. It was a major leap in cosmic photography achieved by linking telescopes worldwide to create a planet-sized interferometer, which provided the necessary resolution to see the unseeable. The photograph itself revealed much more than expected. It gave us a direct look at the event horizon, or the point of no return, where gravitational pull becomes so strong that not even light can escape. This allowed astronomers to confirm several theoretical predictions about black holes' behavior and structure. By observing the glowing gas orbiting at the edge of the event horizon, researchers could measure the black hole's massive influence on its surroundings, offering new insights into how matter behaves in such extreme environments. This not only validated some of Einstein's predictions about general relativity, but also opened new avenues for understanding the fundamental laws of physics in the most extreme conditions known in the universe. The layers of a black hole. Diving deeper into the anatomy of a black hole reveals a complex structure composed of distinct layers, each playing a critical role in its function and behavior. The outermost layer, known as the event horizon, is famously termed the point of no return. It marks the boundary beyond which nothing, not even light, can escape the gravitational pull of the black hole. This layer defines the visible outline of the black hole and acts as a gateway to its mysterious inner workings. Moving closer to the core, we encounter the photon sphere. This is a not-so-well-known layer where gravity is so strong that photons, particles of light, are forced into orbital paths around the black hole. Here, light bends around the black hole in a mesmerizing cosmic dance, creating loops of brilliant light that can sometimes be observed with sophisticated telescopes. The photon sphere is crucial for astronomers trying to see and study black holes indirectly by observing how light behaves in this extreme environment. At the very heart of a black hole lies the singularity, a point where the laws of physics as we know them break down. In this region, matter is crushed to infinite density, and the gravitational pull is infinitely strong. The singularity represents one of the greatest mysteries in modern physics. It's where our understanding of gravity, space, and time is challenged, and where current theories reach their limits. Each layer of a black hole, from the event horizon to the singularity, not only contributes to its intriguing nature, but also offers a unique playground for testing the theories of physics in extreme conditions. The nature and dangers of black holes. Black holes are not just fascinating scientific phenomena, they are also incredibly dangerous regions of space. At the heart of their danger is their intense gravitational pull, a force so strong that nothing, not even light, can escape once it crosses the event horizon. This boundary marks the point of no return. For any object unfortunate enough to get too close, the outcome is both dramatic and fatal. This leads us to the gruesome concept of spaghettification. Imagine you're falling feet first into a black hole. The gravitational pull on your feet would be significantly stronger than on your head, stretching you longer and thinner like spaghetti. This stretching happens because different parts of your body experience different intensities of gravity. Eventually, this effect becomes so extreme that it tears apart anything caught in its grasp, atom by atom. The perils of black holes extend beyond the immediate destruction of material objects. Their presence can disrupt nearby stellar environments, drawing in and accumulating gas, dust, and other celestial debris in a swirling accretion disk. This accumulation can lead to energetic emissions and powerful jets that reshape their cosmic neighborhood. Thus, the very nature of black holes as regions of extreme gravity makes them not only fascinating to study, but also incredibly hazardous to anything within their reach. Recent photographic breakthroughs. In a groundbreaking achievement, scientists have recently managed to capture the first clear images of a black hole, specifically the M87 black hole. This monumental event in astrophysics not only confirms the existence of black holes, but also allows us to peek into the dynamic processes that govern these enigmatic features of our universe. By stitching together multiple photographs taken over several nights, researchers have developed a more comprehensive view of the black hole structure. These images reveal fascinating details about the black hole's behavior, particularly how matter and light behave around this extreme gravitational force. This insight is crucial as it helps scientists understand the accretion processes and the emission of powerful jets that extend thousands of light years into space. The ability to visually observe these phenomena provides unprecedented information, transforming our theoretical knowledge into tangible, observable facts. This data is vital for testing the limits of our current physical theories and potentially guiding us towards new discoveries in black hole dynamics and the fundamental laws of physics. Black hole theories and spinning black holes. In 1963, Roy Kerr revolutionized our understanding of black holes with his groundbreaking model that described not just any black hole, but those that spin. This concept introduced us to the idea of rotating black holes, which differ significantly from the non-spinning versions predicted by earlier theories. Kerr's model proposes that the space around these spinning black holes twists along with them, leading to the formation of something known as the ergosphere. This region, lying just outside the event horizon, is where the effects of the black hole's spin are most pronounced. Matter and radiation can enter the ergosphere and receive energy from the black hole's rotation, potentially being flung out at great speeds. The implications of Kerr's model stretch even further with the theoretical possibility of the Einstein-Rosen bridge, commonly referred to as a wormhole. This hypothetical feature suggests a tunnel-like pathway through spacetime, facilitated by the unique structure of spinning black holes. Theoretically, these bridges could connect two distant points in the universe, or potentially link to parallel universes. While the existence of such wormholes remains speculative, the discussion it sparks among physicists and the general public alike continues to fuel both scientific inquiry and popular fascination with the cosmos. Wormholes and interstellar possibilities. Wormholes capture the imagination as potential shortcuts through the vastness of space-time, offering hypothetical routes that could connect distant or even parallel universes. Derived from Einstein's equations, these intriguing structures are theorized to form tunnels between disparate points in the cosmos, potentially allowing for instantaneous travel across astronomical distances. However, the science behind wormholes is fraught with challenges. Current understanding suggests that while they may theoretically exist, wormholes would likely be highly unstable, collapsing too quickly for anything to pass through without extraordinary amounts of negative energy, something not currently understood to exist in the necessary quantities. This instability has led many scientists to approach the concept of practical wormhole travel with skepticism, maintaining a cautious perspective on the feasibility of using these cosmic phenomena as pathways for interstellar travel. Despite these hurdles, the study of wormholes continues to be a vibrant area of theoretical physics, pushing the boundaries of our understanding of the universe. Superstring theory and its implications. Superstring theory offers a groundbreaking perspective on the unification of the universe's most fundamental forces. This theory suggests that what we perceive as particles are actually tiny, vibrating strings, each resonating at specific frequencies. Unlike traditional particle physics, superstring theory requires a universe with 10 dimensions, far beyond the 4 dimensions of space and time that we experience daily. These additional dimensions aren't just theoretical quirks. They are essential for the mathematics of the theory to work properly, providing a framework that could potentially explain every force and particle in the universe. This bold idea not only bridges the gap between Einstein's theory of general relativity, which governs the cosmos at the largest scales, and quantum mechanics, which reigns over the smallest, but it also offers explanations for phenomena that otherwise defy classical explanations. For instance, superstring theory could elucidate the nature of black holes, which challenge our understanding of both gravity and quantum mechanics. By viewing these cosmic puzzles through the lens of superstring theory, physicists hope to unlock answers to some of the most profound questions about the structure and origins of the universe. Experimental challenges and theoretical developments. Studying black holes presents unique challenges to scientists, primarily because these cosmic phenomena do not emit light, making them invisible to traditional observation methods. Researchers must instead rely on indirect methods, such as observing the gravitational effects black holes have on nearby stars and gas clouds. This indirect approach adds layers of complexity and uncertainty to their studies. Further complicating the study of black holes is the theoretical framework of superstring theory. This advanced theory suggests that all fundamental particles are not point-like dots, but rather tiny, vibrating strings. Superstring theory is a leading candidate in the quest to unify Einstein's theory of general relativity with quantum mechanics. However, it posits the existence of 10 dimensions, 6 beyond the 3 spatial dimensions and 1 time dimension we experience daily. These extra dimensions are theorized to be compact and rolled up so tightly that they are beyond our current capability to observe directly, posing a significant hurdle for empirical validation. The unstable properties of theoretical constructs like wormholes add another layer of complexity. Wormholes, predicted by the equations of general relativity under specific conditions, are passages through spacetime that could, in theory, connect distant parts of the universe or different universes altogether. However, the inherent instability of these wormholes and the extreme conditions likely found at their entrances, such as intense radiation and crushing gravitational forces, make them difficult to study or even confirm their existence scientifically. These challenges mean that much of what we understand about black holes and related phenomena remains speculative, relying on advancing theoretical physics and improving observational technologies to bring these cosmic mysteries into clearer view. The Big Bang and beyond in string theory. String theory offers a fascinating twist on the Big Bang theory, suggesting that what we perceive as the universe's beginning might actually be far more complex. According to this theory, our universe could potentially be the product of two separate universes colliding, or a universe birthing another, akin to a cosmic child emerging from its parent. This interconnection between universes is conceptualized through what's known as wormholes, which are theorized as cosmic tunnels linking disparate parts of the universe or even different universes altogether. The implications of this are staggering. If wormholes are real and stable enough to connect different realms of space-time, our current understanding of our place in the cosmos could be fundamentally altered. It raises the possibility that what we consider black holes might actually be gateways or bridges to other dimensions or distant parts of our universe. This leads to an even more bewildering possibility. Could our entire observable universe be inside a black hole located in a much larger universe? Such a scenario would redefine concepts of beginning and end and what it means to exist in this universe. As we continue to explore these profound questions, the mysteries of the cosmos keep our curiosity piqued, pushing the boundaries of our understanding of the very fabric of reality. We hope you found these facts intriguing. If you've heard them before or have any thoughts to share, please let us know in the comments below. Don't forget to give us a thumbs up and subscribe to A World to Discover to join us on our journey of discovery. While you're still here, feel free to click on other videos you will see on your screen right now. In the quest to find another Earth, scientists have turned their gaze to Proxima b, our closest exoplanet neighbor. But the James Webb Space Telescope's latest image reveals a world that's both tantalizingly similar and alarmingly different from our own.
We have found a planet around the nearest star, Proxima Centauri. So, this discovery didn't happen, obviously, from one day to the next.
So what's the closest Earth-like planet you think is worth visiting? How hard is it?
Proxima Centauri. It's over 4 light years away, and we can't travel at the speed of light. Today, there are plans that have planted the seed that shift this line, how we could send probes there.
The James Webb Space Telescope, humanity's most advanced eye in the sky, has recently captured the clearest image of Proxima b to date. This groundbreaking achievement marks a significant milestone in our understanding of exoplanets and the potential for extraterrestrial life. The unprecedented clarity of this image allows scientists to study Proxima b's features in detail, offering new insights into its composition and environment. As we delve deeper into the mysteries of Proxima b, we find ourselves at the intersection of hope and adversity. The planet's proximity to Earth makes it an enticing target for exploration, yet its harsh conditions pose formidable challenges. In the following sections, we'll explore the complex nature of Proxima b and the technological marvels that have made this discovery possible, unraveling the enigma of our cosmic neighbor. Our closest exoplanet neighbor, Proxima b, our closest exoplanet neighbor, orbits the star Proxima Centauri at a distance of just 4.2 light-years from Earth. This proximity makes it a prime target for scientific study and exploration. Despite its relative closeness, Proxima b remains shrouded in mystery, presenting a complex puzzle that challenges our understanding of planetary formation and habitability. Recent measurements have revealed intriguing details about Proxima b's physical characteristics. The planet has a minimum mass that is 17% greater than Earth's, suggesting it may be more Earth-like than previously estimated. This increased mass could indicate a rocky terrestrial composition similar to our own planet. Adding to its allure, Proxima b completes an orbit around its star every 11.2 Earth days, a remarkably short period that speaks to its close proximity to Proxima Centauri. One of the most exciting aspects of Proxima b is its location within the habitable zone of its star. The habitable zone, often referred to as the Goldilocks zone, is the region around a star where conditions might be just right for liquid water to exist on a planet's surface. This concept is crucial in the search for potentially habitable worlds, as liquid water is considered essential for life as we know it. The significance of Proxima b's position within the habitable zone cannot be overstated. It raises the tantalizing possibility that this distant world could harbor liquid water and, by extension, potentially support some form of life. This prospect has ignited the imagination of scientists and the public alike, fueling dreams of discovering life beyond our solar system. Recent advancements in technology have allowed for more precise measurements of Proxima b's characteristics. The espresso spectrograph, a powerful instrument designed to detect and study exoplanets, has provided new insights into Proxima b's nature. These latest measurements suggest that Proxima b could indeed be a rocky, terrestrial planet similar to Earth, further enhancing its potential for habitability. However, the story of Proxima b is not without its challenges. The planet's close proximity to its star, while allowing it to reside within the habitable zone, also presents significant obstacles. Proxima Centauri, a red dwarf star, is smaller and cooler than our Sun, but it poses unique threats to its planetary companion. The intense radiation emitted by Proxima Centauri raises serious concerns about Proxima b's ability to retain an atmosphere. Without a protective atmospheric layer, the planet's surface would be exposed to harmful stellar radiation, potentially making it inhospitable for life as we understand it. This close dance between planet and star creates a precarious balance, where the very factors that place Proxima b in the habitable zone also threaten its potential to support life. This tension between hope and adversity exemplifies the complex nature of exoplanet research. On one hand, Proxima b's Earth-like mass and position within the habitable zone fuel optimism about its potential to harbor life. On the other hand, the harsh realities of its stellar environment present significant challenges to its habitability. The harsh realities of Proxima b's environment. At the heart of Proxima b's story lies its host star, Proxima Centauri. This celestial body is a red dwarf, a class of stars that differs significantly from our Sun. Red dwarfs are smaller, cooler, and far more numerous than stars like our own. While their cooler temperatures might seem advantageous for nearby planets, the reality is far more complex. Proxima Centauri's diminutive size and lower temperature mean that its habitable zone, the region where liquid water could potentially exist on a planet's surface, is much closer to the star than in our solar system. This proximity creates a host of challenges for Proxima b, our nearest exoplanet neighbor. One of the most significant consequences of Proxima b's close orbit is the likelihood of tidal locking. This phenomenon occurs when a planet's rotation becomes synchronized with its orbit, causing one side to always face its star while the other remains in perpetual darkness. The implications of this are profound. Imagine a world where one hemisphere basks in eternal daylight while the other never sees its sun. This tidal locking leads to extreme temperature variations across Proxima b's surface. the side facing Proxima Centauri likely experiences scorching heat, potentially hot enough to melt rock. In contrast, the dark side might be locked in a permanent frigid night. Between these two extremes, there could be a narrow band, often called the Terminator line, where temperatures might be more moderate. This twilight zone represents one of the few areas where conditions could potentially support life as we know it. However, temperature extremes are just the beginning of Proxima B's environmental challenges. The planet's close proximity to its star exposes it to intense radiation. Red dwarf stars, despite their smaller size, can be incredibly active and prone to powerful flares. These stellar outbursts pose a significant threat to any potential life on nearby planets. In April 2021, astronomers observed a flare from Proxima Centauri that was truly staggering in its intensity. This event was 100 times more intense than any flare recorded from our Sun, demonstrating the volatile nature of Proxima B's cosmic neighborhood. Such powerful flares could strip away a planet's atmosphere over time, leaving its surface exposed to harmful radiation. The radiation environment around Proxima B is further complicated by the star's magnetic activity. Researchers believe that the chaotic surface activity of Proxima Centauri leads to powerful magnetic fields that contribute to the high-energy radiation environment around Proxima B. This constant bombardment of radiation poses a significant challenge to the development and survival of life as we understand it. To put the intensity of this radiation into perspective, consider this. Proxima B experiences solar wind radiation that is approximately 1,000 times greater than what Earth receives. This relentless onslaught of charged particles and high-energy radiation would be devastating to most forms of life familiar to us. Given these harsh conditions, it's natural to question the possibility of life on Proxima B. As one researcher noted, while the idea of a habitable planet orbiting Proxima Centauri is captivating, the reality seems far from hospitable. The combination of extreme temperatures, tidal locking, and intense radiation creates an environment that appears hostile to life as we know it. Another scientist remarked, "It's hard to imagine life surviving such intense radiation without specialized shelter." This statement encapsulates the challenge facing any potential life on Proxima B. To survive in such an environment, organisms would need to develop extraordinary adaptations or find ways to shelter from the constant barrage of radiation. Yet, it's crucial to remember that our understanding of life and its potential forms is limited to what we've observed on Earth. The very challenges that make Proxima B seem inhospitable also push us to expand our concepts of habitability and life itself. Could there be forms of life that thrive in conditions we consider extreme? Might the unique environment of Proxima B foster types of life entirely different from what we're familiar with? Technological marvels, overcoming the odds. In the face of Proxima B's extreme environment, humanity has risen to the challenge with remarkable technological innovations. At the forefront of this endeavor stands the James Webb Space Telescope, JWST, a marvel of engineering that has revolutionized our ability to study distant exoplanets. The JWST represents a quantum leap in space observation technology. Its advanced infrared imaging capabilities allow astronomers to peer through cosmic dust and gas, revealing details of exoplanets that were previously hidden from view. This breakthrough has been particularly crucial in our study of Proxima B, providing unprecedented clarity in imaging our closest exoplanet neighbor. What makes the JWST so exceptional in its ability to study Proxima B? The answer lies in its sophisticated suite of instruments and its strategic position in space. Orbiting the Sun about 1 million miles from Earth, the JWST is shielded from the interference of our planet's atmosphere and the heat of the Sun. This optimal positioning, combined with its large mirror and sensitive detectors, allows it to capture the faintest signals from distant worlds. The JWST's capabilities extend beyond mere imaging. Its instruments can analyze the light passing through an exoplanet's atmosphere, providing crucial data about its composition. This technique, known as spectroscopy, has the potential to detect biosignatures, chemical markers that could indicate the presence of life. While the JWST has captured the headlines, it's not the only technological marvel contributing to our understanding of Proxima b. The espresso spectrograph, installed on the Very Large Telescope in Chile, has played a pivotal role in refining our knowledge of this enigmatic world. Espresso's capabilities allow it to split light from Proxima b into its component wavelengths, enabling detailed analysis of the planet's characteristics. The precision of Espresso's measurements is truly astounding. Francesco Pepe, a co-author of the Espresso study, expressed satisfaction with the instrument's performance, stating, "We're really pleased that Espresso can produce even better measurements." This improved accuracy has allowed scientists to refine their estimates of Proxima b's mass and orbit, bringing us closer to understanding its true nature. Looking to the future, an even more ambitious project is on the horizon, the Starshot Initiative. This groundbreaking concept aims to send a fleet of tiny spacecraft to Alpha Centauri, potentially allowing us to study Proxima b up close. The Starshot project faces significant challenges, including the need for 100 gigawatts of power from 100 million lasers to propel a probe at 20% the speed of light. Despite these hurdles, the potential rewards are immense. If successful, Starshot could revolutionize our approach to space exploration, reducing travel time to Proxima b from thousands of years to mere decades. The technological challenges of the Starshot initiative are formidable. The spacecraft designed for this mission must reflect 99.99% of incoming light to prevent overheating during its journey. Additionally, the Starshot team is exploring the use of adaptive optics to overcome atmospheric interference, allowing for a more focused laser beam on the spacecraft. These innovations push the boundaries of what's currently possible in space technology. Each of these technological marvels, the JWST, Espresso, and the proposed Starshot initiative, represents a testament to human ingenuity and our relentless pursuit of knowledge. They allow us to overcome the vast distances and harsh conditions that separate us from Proxima b, bringing us closer to understanding our cosmic neighborhood. The search for life, hope amidst adversity. Proxima b stands as a testament to the complexity of our cosmic neighborhood. Its status as our closest exoplanet neighbor, coupled with its location within the habitable zone of Proxima Centauri, makes it a prime candidate for potential life. However, the harsh realities of its environment present significant challenges to this possibility. The planet's Earth-like mass and position within the habitable zone initially fueled optimism about its potential to harbor life. These factors suggest that Proxima b could have a rocky composition and might support liquid water on its surface, two crucial elements in our search for habitable worlds. Yet, the very proximity to its star that places Proxima b in the habitable zone also exposes it to extreme conditions that could render it inhospitable. The intense radiation from Proxima Centauri, particularly the powerful flares observed in recent years, poses a significant threat to any potential life on the planet. This constant bombardment of high-energy particles could strip away Proxima B's atmosphere over time, leaving its surface exposed to harmful radiation. The likely tidal locking of the planet further complicates matters, creating extreme temperature variations across its surface. In the midst of these challenges, a recent discovery has reignited interest in the search for life beyond our solar system. Astronomers detected a mysterious signal from the Alpha Centauri system at a frequency of 982.07 MHz. This finding has sparked speculation about the possibility of intelligent life in our cosmic backyard. While some experts suggest that the signal might originate from manufactured equipment, others remain cautiously optimistic that it could indicate extraterrestrial intelligence. The discovery of this signal serves as a stark reminder of the potential for groundbreaking discoveries in our quest to understand the universe. It underscores the importance of continued exploration and study of nearby star systems, including Proxima Centauri and its intriguing exoplanet, Proxima b. Studying Proxima b offers a unique opportunity to refine our understanding of what makes a planet truly habitable. By examining how extreme conditions affect the potential for life, scientists can expand their criteria for habitability beyond Earth-like standards. This approach could lead to new insights into the resilience and adaptability of life in diverse environments. The harsh conditions on Proxima b challenge us to reconsider our definitions of life and habitability. Could there be forms of life that thrive in environments we consider extreme? Might the unique conditions on Proxima b foster types of life entirely different from what we're familiar with on Earth? These questions push the boundaries of our scientific understanding and imagination. As we gather more data about Proxima b, we are compelled to balance scientific possibility with the harsh realities of space environments. While the planet's proximity and location within the habitable zone offer hope, the intense radiation and extreme temperature variations present significant obstacles. This delicate balance between optimism and realism drives the continued exploration and study of our nearest exoplanet neighbor. The James Webb Space Telescope's recent capture of the clearest image of Proxima b to date marks a significant milestone in our understanding of this enigmatic world. This technological achievement allows scientists to study Proxima b's features in unprecedented detail, offering new insights into its composition and environment. Such advancements bring us closer to unraveling the mysteries of our cosmic neighbor and potentially answering the age-old question: are we alone in the universe? Future prospects. The road to Proxima b. The journey to Proxima b represents one of humanity's greatest challenges in space exploration. With current technology, reaching our nearest exoplanet neighbor would take approximately 6,000 years. This staggering time frame underscores the vast distances that separate us from even our closest cosmic neighbors. It's a stark reminder of the limitations we face in our quest to explore the universe beyond our solar system. However, human ingenuity continues to push the boundaries of what's possible. Enter the Starshot Initiative, an ambitious project that aims to drastically reduce the travel time to Alpha Centauri, the star system that hosts Proxima b. This groundbreaking endeavor targets a journey of just 22 years, a fraction of the time required by conventional spacecraft. The Starshot project proposes to achieve this feat through a revolutionary approach to space travel. It plans to utilize a fleet of small probes, each about 10 meters in diameter, propelled by powerful lasers. These spacecraft would travel at an astonishing 20% of the speed of light, enabling rapid exploration of Proxima b and its surroundings. The scale of this undertaking is truly mind-boggling. The Starshot initiative requires an immense power output of 100 gigawatts, equivalent to the entire electricity consumption of the United States. However, this enormous power would only need to be sustained for about 10 minutes to launch the probes on their interstellar journey. Once launched, these probes would embark on a 2-decade journey across the cosmic void. Upon reaching Alpha Centauri, they would have approximately 2 hours to gather data and transmit it back to Earth. This transmission would then take an additional 4 years to reach us, adding to the complexity of interstellar communication. The potential impacts of successfully exploring Proxima b extend far beyond the realm of scientific discovery. Such an achievement would mark a new chapter in human history, fundamentally altering our perspective on our place in the universe. It would provide unprecedented insights into the nature of exoplanets, potentially answering age-old questions about the prevalence of life beyond Earth. From a philosophical standpoint, the exploration of Proxima b challenges us to reconsider our role as a species. It pushes us to contemplate the possibilities and responsibilities that come with becoming an interstellar civilization. The knowledge gained from such a mission could reshape our understanding of planetary formation, evolution, and the conditions necessary for life to emerge and thrive. However, as we contemplate the exploration and potential colonization of other worlds, we must also grapple with significant ethical considerations. The idea of altering another planet's environment raises complex questions about our rights and responsibilities as cosmic explorers. Should we intervene in the natural processes of other worlds? What precautions should we take to prevent contamination or unintended consequences? These ethical dilemmas become even more pronounced if we were to discover any form of life on Proxima b, no matter how primitive. The potential impact on indigenous life forms, even microbial ones, must be carefully considered in any exploration or colonization efforts. A new chapter in space exploration. The exploration of Proxima b marks a new frontier in our quest to understand the universe. This enigmatic world, both tantalizing and treacherous, challenges our notions of habitability. Its Earth-like mass and position in the habitable zone offer hope, while its harsh radiation environment and extreme temperatures present significant obstacles. Technological marvels like the James Webb Space Telescope and espresso spectrograph have revolutionized our ability to study this distant world, providing unprecedented clarity and detail. The potential Starshot initiative represents humanity's ambition to bridge the vast distances of space. As we continue to unravel Proxima b's mysteries, we expand our understanding of what makes a planet truly habitable and push the boundaries of our technological capabilities. This journey of discovery reflects humanity's enduring drive to explore the unknown, even in the face of seemingly insurmountable challenges.
The successor to the Hubble telescope, just about ready now to produce images of the universe like we have never seen before.
It's also one of the most complicated pieces of technology ever built. It contains over 3,000 sensors that continuously monitor the status of the hardware, so that technicians on the ground can keep an eye on what's happening.
The Hubble Space Telescope, humanity's eye into the vastness of space, has reportedly captured an image so mysterious, it stirred up more questions than answers. This isn't just any celestial body or distant galaxy we're talking about. This is something otherworldly. Today we're unraveling the tale of the City of God, a celestial phenomenon that has sparked debates, curiosity, and perhaps even a bit of fear. From a leaked photograph that took the world by storm to government cover-ups, and the eerie sighting of celestial beings, This story has all the makings of a cosmic thriller. But what is the truth behind these bewildering claims? Are we on the verge of uncovering a divine presence in the universe, or is this a case of cosmic misinterpretation? And finally, if the City of God is real, what implications does it have for humanity's place in the universe?
Hubble has consistently taken us to places we've never been, visually, of course, and empowered us to answer questions that in a previous generation of telescopes we couldn't even pose.
So I think what excites me is that it shows us the wonder of the universe, places we can't get to right now.
NASA's achievements. Since the monumental day when man first set foot on the moon, NASA has not just rested on its laurels but has pushed the boundaries of what we believed was possible. With a brilliant team comprising the brightest minds in science, astronomers, engineers, and researchers, NASA has been the driving force behind the creation of spacecraft that seem to leap straight out of science fiction. These marvels of engineering have traversed the galaxy, sending back information that has unveiled the cosmos layer by layer. Each mission, from the Mars rovers to the Voyager probes, has been a thread in the rich tapestry of space exploration, revealing the mysteries of our solar system and beyond. But it's not just about the destinations, it's also about the incredible journeys. The development and deployment of the Hubble Space Telescope stand as a testament to NASA's ingenuity and quest for knowledge. Hubble, orbiting Earth, has acted as humanity's window to the universe, capturing images that have not only advanced our understanding of the cosmos, but have also inspired millions around the globe with stunning visuals of distant galaxies, nebulas, and stars. Through decades of dedication, NASA's efforts have peeled back the layers of the cosmos, revealing the beauty and complexity of the universe in unprecedented detail. These achievements are not just milestones in the annals of space exploration, but are beacons of human curiosity and our unyielding desire to explore the unknown. Terrifying image discovery. In one of the most electrifying updates from the cosmos, the Hubble Space Telescope has sent back an image that sent shockwaves through the scientific community and beyond. This isn't your ordinary snapshot of distant stars or swirling galaxies. No, this image is different. It's been described as terrifying, not because of its eerie aesthetics, but because of the profound questions it raises about our very existence in the universe. Imagine the Hubble orbiting silently in the cold vacuum of space, its lens trained on the infinite cosmos. It captures countless wonders on a routine basis, from the birth of stars to the death of galaxies, each image a testament to the natural beauty of the universe. But among these routine captures, there emerges an image so unexpected, so out of place, it takes everyone by surprise. The image reveals what appears to be a structure, a composition so precise and unfamiliar that it defies all conventional understanding of cosmic formations. The immediate reaction is one of disbelief and shock. Scientists, used to deciphering the mysteries of the universe, find themselves at a loss, questioning not only the nature of this discovery, but also its implications for humanity's understanding of the cosmos. This is no mere celestial anomaly. Its presence suggests that there could be aspects of the universe that are entirely unknown to us, hidden realms or civilizations that exist beyond our current scientific comprehension. The potential impact of this discovery on our understanding of existence is monumental. It challenges the very foundations upon which our cosmic knowledge is built, inviting us to reconsider what we thought we knew about the universe. Alleged discovery of heaven. The core of our story revolves around an alleged photograph leaked from none other than NASA itself. This isn't just any photo. We're talking about a snapshot that reportedly reveals a sprawling, large white city floating in the void of space. Captured on December 26, 1994, this image quickly transcended from a confidential discovery to a global phenomenon, sparking shock and awe not just among the public, but within the scientific community as well. What makes this story even more intriguing is the context and the timing of the discovery. It came from the Hubble Space Telescope, humanity's most advanced eye in the sky, which has been peering into the deepest recesses of the universe since its launch in 1990. The photograph in question surfaced at a time when the internet was just beginning to weave its web around the globe, a period ripe for rapid information exchange and, of course, speculation. Imagine the scene in NASA's offices when scientists first laid eyes on this baffling image. It was unlike anything they had seen before, a celestial anomaly that defied immediate explanation. The initial shock among the team was palpable. Here was a highly sophisticated space telescope designed to explore the cosmos and answer humanity's most profound questions, presenting them with an image that seemed to raise more questions than answers. The photographs leaked to the public turned the scientific curiosity into a wildfire of speculation. The idea of a city floating in space challenges our understanding of the universe, provoking discussions about the nature of celestial bodies, the possibility of other civilizations, or even the concept of a heavenly abode. As this image made its rounds across the nascent internet, it became a subject of fascination, debate, and wonder. People from all walks of life weighed in with their interpretations, theories, and understandably, their skepticism. The scientific community was left to grapple with the implications of such a discovery, while the public imagination ran wild with the possibilities of what this city could represent. Public and governmental reaction. In today's digital age, the line between the extraordinary and the unbelievable blurs faster than a shooting star streaking across the night sky. But what happens when a discovery so monumental comes to light? It threatens to unravel the fabric of our reality. This is the story of an image captured by the Hubble Space Telescope that did just that. A photograph depicting what many have come to call the City of God, a celestial marvel that has set the internet ablaze with speculation, wonder, and a fair share of skepticism. Within moments of its alleged leak, the image coursed through the veins of the internet, igniting discussions in every corner of the globe. Chat rooms, forums, and social media platforms became the stages for heated debates and wild theorizing. The picture, showing a vast, white city amidst the stars, was nothing short of a revelation. A glimpse into the divine, or perhaps a cosmic anomaly yet to be understood. But with great revelation comes great responsibility and perhaps great panic. The US government, sensing the potential for public unrest in the wake of such a bewildering discovery, moved swiftly, albeit not swiftly enough. Before the images could be tucked away into the classified archives, they spread far and wide, a testament to the age-old adage, once on the internet, always on the internet. The attempt to classify the images was seen by many as a knee-jerk reaction to control the narrative, to keep the public in the dark about a discovery that could redefine human existence itself. This action, rather than quelling curiosity, only fueled it further, leading many to question what else might be hidden within the vaults of governmental secrecy. As the images continued to circulate, the line between fact and fiction blurred. Skeptics called it a hoax, a clever manipulation of light and shadow. Believers saw it as proof of the afterlife, a celestial city awaiting us all. The truth, as it often does, lay somewhere in between, shrouded in the mystery of the cosmos and the limitations of human understanding. Further analysis and observations. Now let's dive into further analysis and observations of the anomaly initially captured by the Hubble Space Telescope. After the initial shockwave caused by the leaked images of a supposed celestial city, NASA's finest minds convened in an urgent effort to clarify the mysterious findings. With the world buzzing with theories and speculation, the decision was made to task the Hubble telescope with a mission of utmost importance. This wasn't merely a second glance. It was a full-scale, high-resolution investigation aimed at piercing the veils of the cosmos to uncover the truth behind the anomaly known as the City of God. Equipped with cutting-edge technology, the Hubble was meticulously programmed to capture the anomaly in the highest possible resolution. Scientists were not just looking for answers, they were seeking undeniable proof of what the structure truly was. The stakes were as high as the anticipation that filled the laboratory air. As the Hubble telescope focused its lenses on that specific section of the starry sky, hearts raced. The gathered scientists and astronomers knew they were on the cusp of potentially rewriting history. The subsequent capture of the photograph was a moment of truth. With bated breath, the image was projected onto a very big screen, instantly seizing the undivided attention of everyone present. What was revealed was nothing short of astonishing. The previously foggy and ambiguous spot was now clear, unveiling a structure that was at once luminous and architecturally complex. It was as if a light was shining from within the structure itself, casting an otherworldly glow across the cosmos. This presumed city, with its resemblance to speculative fiction and futuristic depictions, stretched into the vast expanse of space, igniting a myriad of questions and theories. Skeptical views and scientific inquiry. In a twist that's as intriguing as the discovery itself, the narrative shifts gears, ushering us into the realm of skepticism and scientific inquiry. This turn of events throws a shadow of doubt over the celestial spectacle, painting it with strokes of uncertainty and speculative fiction. As we delve deeper, it becomes clear that not everyone is ready to take the leap from observable science to the acceptance of a city of God floating in the cosmos. The skepticism isn't without reason. The scientific community, known for its rigorous standards of proof and evidence, finds itself at a crossroads. The image, while mesmerizing, raises as many questions as it purportedly answers. Could this be a case of cosmic pareidolia, where human perception sees familiar patterns in random or vague images? Or perhaps a misinterpretation of astronomical data, transformed into a narrative more suited to science fiction than to empirical science? The narrative underscores the potential for overinterpretation, a common pitfall in the quest to make sense of the unknown. With excitement reaching feverish heights, the distinction between hard evidence and the allure of speculative fiction becomes blurred. This skepticism serves as a reminder of the importance of grounding extraordinary claims in solid scientific methodology and evidence. As the story unfolds, the skepticism doesn't just challenge the veracity of the City of God, but also ignites a broader discussion about the nature of discovery and the human inclination to find meaning in the mysteries of the universe. It poses an essential question to us all. Where do we draw the line between the pursuit of knowledge and the seductive pull of storytelling that ventures into the realms of speculative fiction? The city's movement and cosmic role. As scientists scrutinized the images captured by the Hubble Space Telescope, they uncovered a movement that aligns with the grand cosmic bolide. The city doesn't merely float in space. It follows a path that adheres to the fundamental laws of the universe we thought we understood. But here's where it gets even more fascinating. The city is described as acting almost like a cosmic lighthouse, a point from which galaxies seem to drift away. This movement isn't random chaos. It's orderly, following the principles laid out in the Big Bang Theory, suggesting that this city is not just a part of the universe, but a central figure in its expansive dance. This revelation sends ripples through our current cosmological models, challenging the way we perceive the structure and dynamics of the cosmos. Imagine a model of the universe where Earth isn't at the center, nor is the Sun, but perhaps this mysterious city of light. Scientists have even employed computer models to illustrate how galaxies drift away from this enigmatic point, inviting us to reconsider our place in the universe's vast tapestry. What does this mean for our understanding of cosmic movements and the forces that govern them? Are we looking at a gravitational anomaly, a celestial mirage, or a beacon from which the universe itself expands? Allegations of NASA hiding the discovery. As the story unfolds, we find that following the initial leak of this extraordinary image, the reaction was swift and shrouded in secrecy. The US government allegedly stepped in with a heavy hand, classifying the images to stifle the swell of public unrest. This wasn't merely a routine operation. It was an act driven by the fear of the unknown, a testament to the potentially destabilizing impact of the discovery on societal norms and beliefs. But the plot thickens. Despite efforts to keep the images under wraps, a photographer at Ellington Airfield, armed with nothing more than a camera and a keen eye, managed to capture snapshots of the supposed celestial marvel. These images, adorned with structures that seem to defy human comprehension, found their way onto the internet, igniting a firestorm of speculation and debate. In the heart of this intrigue lies a critical question. Why would NASA, an institution dedicated to the pursuit of knowledge and the dissemination of cosmic discoveries, choose the path of secrecy? The implications of such a decision are profound, suggesting a discovery so impactful, so revolutionary, that it compelled a response aimed at controlling the narrative to keep the public in the dark. Decoding the image for further evidence. As we decode this image, we're confronted with formations that seem impossibly structured, bearing an uncanny resemblance to the architectural feats of an advanced civilization. towers that stretch towards the stars, domes that shimmer with an ethereal glow, and perhaps most intriguingly, figures that appear distinctly lifelike. These elements have thrown the scientific community into a whirlwind of speculation and debate. But what makes these formations stand out is not just their apparent artificiality. It's their placement within the vastness of space, a location where no human architect could have possibly erected them. The detailed analysis brings forward more questions than answers. How could such structures exist in the void of space? Are these truly the makings of an advanced civilization? Or is there a more mundane explanation, one rooted in the bizarre and often deceptive nature of cosmic phenomena? As we explore this celestial mystery, we must consider the possibilities. Could optical illusions, a common trickster in astronomy, be at play here? Or have we stumbled upon a discovery that challenges our very understanding of the universe? The implications of this image are as vast as space itself, inviting us to ponder not just on the origins of these anomalous structures, but on the very nature of existence beyond our earthly confines. Angels and celestial phenomena. Alongside the images of the celestial city, there have been reports of figures resembling angels in the vicinity, adding a layer of mystique to an already extraordinary discovery. This isn't a scene from a science fiction novel. These reports come from meticulous observations, with the figures described as having brilliant orange hues, massive wingspans akin to that of airplanes, and an appearance of joy as if they were reveling in the act of being photographed by humanity's most advanced telescope. This narrative isn't without precedent. In an echo from the past, Soviet cosmonauts during the Soyuz mission reported encountering a band of bright, smiling angels in space, suggesting that what the Hubble has captured might not be an isolated phenomenon. These historical encounters present us with a tantalizing question. Have we, across the years and through the lens of different cultures and technologies, been witnessing the same celestial phenomena? The implications of these sightings are profound, bridging the gap between the known and the unknown, the scientific and the mystical. As we delve deeper into the cosmos, these encounters remind us of the vastness of the universe and the possibility of realities beyond our current comprehension. Public and cultural reaction to the discovery. The City of God image, allegedly captured by the Hubble Space Telescope, became a mirror reflecting humanity's deepest yearnings and beliefs. Across the globe, people from all walks of life found themselves grappling with the implications of this celestial phenomenon. Was this the architectural manifestation of the divine, a celestial abode among the stars? The very thought seemed to bridge the gap between science and spirituality, offering a tantalizing glimpse into the eternal. The reaction was as diverse as it was intense. For some, the discovery affirmed long-held beliefs in a celestial beyond, while for others, it sparked curiosity and a revaluation of their understanding of the universe. Social media platforms and internet forums buzzed with theories and interpretations, showcasing humanity's unquenchable thirst for understanding the mysteries of existence. In this period of collective reflection and wonder, the City of God became more than just a potential cosmic discovery. It evolved into a cultural phenomenon. It prompted discussions not only about the scientific implications, but also about the philosophical and spiritual questions it raises. How do we reconcile our place in the universe with such revelations? What does it mean for our understanding of life, existence, and the afterlife? Comparative analysis with past claims. This isn't the first time humanity has been captivated by the idea of celestial cities or heavenly bodies lurking in the vastness of space. Remember the buzz around the gates of heaven? Back in 2016, an image allegedly showing the entrance to the celestial realm made rounds online, sparking awe and debate. However, it turned out to be a work of art, a creative interpretation of cosmic phenomena, not an actual celestial gateway. This pattern of sensationalism isn't limited to just heavenly cities or gates. Over the decades, numerous claims have surfaced, suggesting that NASA has stumbled upon evidence of the divine or the extraterrestrial. These narratives often gain traction quickly, fueled by humanity's innate curiosity and fascination with the unknown. Yet, time and again, upon closer scrutiny, these claims are grounded more in imagination than in empirical evidence. The allure of finding divine or otherworldly signs in the cosmos is undeniably strong. It speaks to our deepest questions about existence, spirituality, and our place in the universe. The City of God narrative, with its descriptions of towering structures, angelic beings, and a celestial city that moves with the galaxies, taps into this allure. It presents a cosmic mystery wrapped in the veneer of divine revelation. But as we've seen with past claims, the excitement of such discoveries often outpaces the reality of the evidence. The Hubble Space Telescope, a marvel of modern science, has indeed revolutionized our understanding of the cosmos, revealing the universe's beauty and complexity in unprecedented detail. Yet its findings are subject to the same rigorous scrutiny and scientific standards as any other scientific endeavor. Debunking and rational skepticism. Historical precedents remind us to tread carefully when interpreting celestial photographs. Recall, for instance, the 2016 incident involving an image purported to showcase the gates of heaven. Initially captivating the public's imagination, this image was later revealed to be a work of art, not an authentic celestial snapshot. The artist, utilizing a technique known as pixel sorting, transformed an actual Hubble image of the Swan Nebula into the so-called Gates of Heaven, inadvertently igniting a flurry of speculative claims. This isn't an isolated case. The Weekly World News, known more for sensational stories than scientific reporting, published the original story about heaven being photographed by the Hubble telescope. While engaging, the publication's track record invites skepticism regarding the authenticity of such claims. Further inquiry into the story's foundation reveals a pattern of misinterpretation and occasionally outright fabrication of celestial phenomena. Moreover, when examining the supposed images of the City of God, the presence of diffraction spikes becomes a point of contention. These spikes, characteristic of images captured by mirror-based telescopes, are often misinterpreted by the untrained eye. However, their presence, shape, and orientation can reveal the source of an image, shedding light on its authenticity. In the case of the City of God, discrepancies in these details hint at the possibility of manipulation or misrepresentation. In the cosmic quest for understanding, the line between discovery and deception can be thin. As we've seen with the City of God, what begins as a captivating visual can lead us down a path of speculative fiction rather than empirical truth. The history of space exploration is dotted with instances of misinterpretation and the allure of finding the divine in the cosmos. Yet, each of these moments serves as a reminder of the importance of critical thinking and the need for rigorous scientific scrutiny. What do you think about this? We hope you found these facts intriguing. If you've heard them before or have any thoughts to share, please let us know in the comments below. Don't forget to give us a thumbs up and subscribe to A World to Discover to join us on our journey of discovery. While you're still here, feel free to click on other videos you will see on the screen right now.
NASA says its Voyager 1 probe, the most distant human-made object in the universe, is sending usable information to Earth again.
The universe is a vast and awe-inspiring place, and although Earth is an incredible planet, it is just a tiny speck in the grand scheme of things. With the advancement of technology, humans have been able to launch rockets and satellites into space, leading to an insatiable thirst for knowledge about the mysteries of the universe. While we have a decent understanding of how the universe works, much of our information is based on conjecture and speculation. That's why space probes like Voyager 1 and Voyager 2 are so crucial to our comprehension of the cosmos. These probes are beaming back real-time data, shedding light on the farthest reaches of our solar system and interstellar space, which we may not be able to visit for many years to come. But what happens when this data includes a terrifying warning that changes everything we thought we knew about the universe? Join us as we delve into what Voyager has discovered so far and the unsettling message it has sent us about the future. For nearly half a century, the Voyager missions have been at the forefront of space exploration, providing invaluable insight into the mysteries of our solar system. It's hard to believe that these missions were not intended to last this long, given the wealth of information they have yielded. The story of how the Voyager program came to be is a fascinating one. It all began with a fortuitous discovery by Michael Minovich, who realized that a spacecraft could use the gravity of a planet to slingshot further into space. This led to the launch of Voyager 1 and Voyager 2 in 1977, with the aim of studying Jupiter and Saturn. What followed was nothing short of a miracle. Both Voyagers are equipped with 3.7-meter radio dishes and 16 thrusters, to adjust their orientation and direct their dishes towards Earth. Their engines use hydrazine fuel, and their electronic components are powered by plutonium-fueled thermoelectric generators. Both carry 11 scientific instruments, half of which were designed to study planets and have since been turned off. The grand tour of the 4 planets has now become a remarkable achievement in human exploration. Voyager 2 successfully completed the first ever close observations of Uranus in 1986 and Neptune in 1989, while Voyager 1 overtook Voyager 2 a few months after launch, passing Jupiter in 1979 and Saturn in 1980, and has become the farthest distant artificial object from Earth. While Voyager 2 still has 5 functioning instruments, Voyager 1 only has 4, but they both remain crucial for gathering valuable data on the deep reaches of space. Today, the 2 spacecraft continue to journey beyond the Sun's influence and into interstellar space, sending back valuable data on the cosmic environment. Before delving into the messages received from Voyager 1, let's first look into some of the discoveries and things both the Voyagers encountered along the way. Imagine embarking on an epic journey to explore the uncharted depths of our solar system with 2 trusty spacecrafts as your companions. Your first mission? Take a closer look at the mighty Jupiter and Saturn systems. And boy, did those probes deliver! They transmitted a plethora of never-before-seen images and gathered extensive data, completely revolutionizing our understanding of these gas giants and the iconic ringed planet. But while Voyager 1 bid adieu to our solar system and ventured into interstellar space, Voyager 2 still had some exciting pit stops in store. In 1981, a corrective maneuver was made to set Voyager 2 on a course towards Uranus. And after exceeding its originally predicted lifespan twice, the spacecraft finally arrived at the remote ice giant in January 1986. But that was just the beginning. On its way to Uranus, Voyager 2 discovered 10 previously unknown moons, adding to the growing celestial family. But the ultimate destination was Neptune, where Voyager 2 captured more than 9,000 images and made an incredible discovery: 9 previously unknown moons. But that wasn't all. Triton, the largest of Neptune's moons, had some fascinating secrets to reveal. It turns out that Triton's diameter was not as previously thought, and the satellite had surprisingly few impact points on its surface. And its brown-white coloration? Geysers. These volcanic formations spew out liquid nitrogen that freezes into white nitrogen snow upon landing on the surface. With these incredible discoveries, the Voyager mission left an indelible mark on our understanding of our cosmic neighborhood. No other spacecraft has revisited Uranus and Neptune after Voyager 2's journey. However, scientists have still been able to observe and study incredible phenomena on these planets from afar. And now, get ready to be amazed as we reveal the secrets of these mysterious spectacles. Uranus. When it comes to ice giants in our solar system, the list is pretty short with only 2 members, Uranus and Neptune. Despite the name, the majority of these planets' material is not actually frozen, but instead consists of hot, supercritical fluids made up of volatile chemical compounds like water, ammonia, and methane. It's a state of matter that combines the properties of liquids and gases. At an average solar distance of 1.8 billion miles, Uranus is the second outermost planet in our solar system, and its diameter is over 4 times that of Earth. It takes Uranus about 84 years to orbit the Sun, and during that time it does something strange. It appears to be lying on its side. The reason for this peculiar axis inclination is unknown, but scientists think it may have collided with a large protoplanet early on. This could also explain the 27 moons orbiting Uranus, which may have formed from the debris of the collision. And if that's not enough to intrigue you, a massive white spot was discovered on Uranus's upper atmosphere about 10 years ago thanks to the Hubble Space Telescope. It turned out to be a gigantic storm whipping around at speeds of up to 89 miles per hour, larger than the United States. But if you think that's wild, imagine the freezing temperatures of Uranus's methane and ammonia clouds, which can drop to a chilling -323 degrees Fahrenheit. And don't forget, just like Saturn, Uranus has its own ring system, although it's much sparser and less abundant. Neptune. In 1846, a bluish shimmering planet was added to the star charts, and we named it Neptune. This outermost planet of our solar system is nearly 3 billion miles away from the Sun, making it quite the loner. To put that in perspective, the distance between Earth and the Sun is only about 90 million miles. Despite its distance, Neptune is similar in size to its ice giant neighbor Uranus, with a diameter of 31,000 miles. However, in terms of mass, Neptune takes the cake with a whopping 17 Earth masses compared to Uranus's 14.5 Earth masses. Neptune takes a whopping 165 years to orbit around the Sun, but it spins quite quickly on its axis, taking only 16 hours to complete one rotation. When NASA's Voyager 2 spacecraft visited Neptune in 1989, it captured some wild weather phenomena such as bright bands of clouds in the atmosphere and storms that reached top speeds of up to 1,305 miles per hour, the fastest winds observed on any celestial body. Experts believe that the lack of solar energy reaching Neptune allows these storms to whip up to such incredible speeds, but there is a chance they may disappear into thin air one day. During the Voyager 2 mission, scientists discovered the Great Dark Spot, a massive formation as large as Eurasia that was believed to be a hole in the planet's visible cloud cover. However, when scientists attempted to find the spot again a few years later, it was nowhere to be found. Some theories suggest that heat from Neptune's core caused turbulence in the atmosphere and tore the structure apart. Speaking of Neptune's core, despite the volatile nature of this planet, scientists believe it has a massive heart. The core is estimated to be 1 to 1.5 Earth masses and composed of metal and rock, with temperatures likely reaching nearly 13,000 degrees Fahrenheit and pressures estimated at several million bar. The magnetic fields of Uranus and Neptune have been a source of wonder for scientists for a long time. These invisible forces have a peculiar characteristic. They are tilted towards the rotation axis and deviate significantly from the planet's physical center. No one has yet unraveled the mystery behind these curious alignments. One thing that is certain is that Neptune's magnetic field is 27 times stronger than Earth's. On the other hand, Uranus's magnetic field is surprisingly weaker than our home planet's. Experts believe that the magnetic fields of these gas giants are generated by movements in comparatively small depth, possibly caused by ionized water. But that's not the only secret that lies within these planets. It is widely believed that Uranus and Neptune have massive cores surrounded by dense layers consisting of hydrocarbons, ammonia, and water. Scientists have been intrigued by the incredible processes that might be happening under the immense pressures at the center of these planets. One fascinating theory suggests that diamonds are raining inside Uranus and Neptune. This idea, which was once merely a thought experiment, was actually proven by a group of researchers a few years ago. The team used polystyrene, a plastic made up of hydrogen and carbon atoms, to recreate the extreme pressure conditions inside the ice giants. They sent 2 shock waves through the substance to see whether the hydrocarbon compounds would split under such pressure. The experiment generated a pressure of 1.05 million bar and raised the thermometer to a scorching 9,000 degrees Fahrenheit. The result was an astonishing shower of glittering diamonds, as nearly all the carbon atoms joined together to form tiny diamond structures. The diamonds that form in Uranus and Neptune would be much larger than those simulated in the laboratory. After they are created, these cosmic gems sink gradually towards the planet's core over a period of thousands of years. The thought of diamond rain on other planets is truly mind-boggling and adds to the intrigue and fascination of these mysterious gas giants. Over the past decade, the 2 probes have ventured into a vast and mysterious region known as the interstellar medium, the space between stars filled with sparse material. And they're still uncovering new discoveries. One of the most surprising findings is the strength and direction of the interstellar magnetic field, which has sparked lively debates among experts about the shape and activity of the Sun's magnetic domain, the heliosphere. Previously thought to be shaped like a comet, the heliosphere may actually be more spherical. and what happens to the heliosphere when sunspots appear and disappear. The spacecraft has provided some intriguing clues. When the solar wind, a flow of charged particles emanating from the sun, comes to a halt, it marks the beginning of the interstellar medium. This ionized gas or plasma is like a rock in a river, pushing against the cooler, denser plasma flowing around it. The sun-carved cavity that forms is called the heliosphere, with its edge called the heliopause, similar to how the top of Earth's troposphere is called the tropopause. Don Gannett, a University of Iowa researcher who worked on the Voyager mission, says that when the spacecraft launched, they had no idea how far the heliopause was. Some speculated it could be as close as Jupiter, which is only 5 times further from the Sun than Earth. But as Voyager ventured further, estimates of the heliopause's distance increased, ruling out Jupiter, Saturn, Uranus, and Neptune. No one knew when or where the spacecraft would enter interstellar space. According to Don Gurnett, shortly after Voyager passed by Neptune, it detected signs of the heliopause in the distance. The spacecraft picked up strong radio waves between 2 and 3 kilohertz in July of 1992, which were later attributed to 6 significant flares on the Sun that occurred over a year prior. The researchers found that the plasma from the flares eventually made its way to the heliopause, where it caused electrons to oscillate and release radio waves. The frequency of these radio waves implied a density matching that expected for the interstellar medium, revealing that the local interstellar medium is far denser than the outer heliosphere. Despite appearing like a pure vacuum on Earth, it is actually quite tenuous. By calculating the speed of outbound solar material and the time it took to hit the boundary, the distance of the heliopause from the Sun was revealed to be between 116 and 177 astronomical units, providing a fascinating insight into our solar system's outer boundaries. When Gannett claimed that Voyager had detected radio waves at the heliopause, he was met with skepticism from many scholars. Not only were these radio waves unprecedented, but Gurnett's interpretation of them also suggested that the heliopause was located at a significant distance from the Sun. To put this into perspective, the distance between the Sun and Neptune is just 30 astronomical units, while the heliopause seemed to be much farther away. Despite these doubts, Voyager 1 successfully crossed the heliopause at a distance of 121.6 astronomical units, consistent with Gurnett's prediction. However, due to the controversy surrounding the claim, NASA decided to delay the announcement of the accomplishment for over a year, although Voyager 1 did observe some indications that it had left the heliosphere, such as a decrease in high-energy particles from the Sun and an increase in cosmic rays from beyond the solar system, many researchers were still not convinced. One issue was that Voyager's plasma instrument had stopped functioning, making it impossible to measure the sudden increase in particle density that occurs when leaving the heliosphere. Additionally, it was expected that the magnetic field would point in a different direction beyond the heliosphere, but this did not happen. Even today, scientists are still scratching their heads trying to explain why the magnetic field outside the heliosphere aligns with the magnetic field inside. It's a mystery that has yet to be solved. Voyager's incredible journey was partly aided by the Sun's outbursts. In 2012, massive solar storms stirred the plasma Voyager 1 traveled through, causing electrons to emit radio waves. These waves indicated that Voyager had entered a denser region of space. On November 5, 2018, Voyager 2 also crossed the heliopause without raising concerns. Its plasma instrument recorded a significant spike in particle density and higher temperatures, likely due to plasma compression when entering the heliosphere. Like Voyager 1, Voyager 2 observed the disappearance of solar wind and an increase in cosmic rays, with an unchanged magnetic field. Stamatios Tom Krimiges of Johns Hopkins University noted that both spacecraft crossed at similar distances, despite different solar cycles in 2012 and 2018. The heliosphere, influenced by the waxing and waning of sunspots over an 11-year cycle, expands and contracts. Despite lower solar wind pressure in 2012 than in 2018, The similar distances suggest the heliopause is more resilient than previously thought. Despite the exact form of the heliosphere remaining a mystery, Voyager 1 and Voyager 2 continue to sail away from it. By the end of this year, Voyager 1 will be 155 astronomical units from the Sun, with signals taking over 22 hours to reach us. Voyager 2 will be 129 astronomical units away and is set to pass Pioneer 10 in late 2023 to become the second furthest spacecraft ever. These spacecraft are now further apart from each other than from Earth. In May last year, Voyager 1's Attitude Articulation and Control System, AACS, began sending confusing data. Despite this, the spacecraft remained in good shape, with a strong, steady signal indicating the antenna was still pointed at Earth. The AACS continued to experience issues, but the science systems functioned normally. NASA identified the problem as the AACS transmitting telemetry via a long-defunct onboard computer. Engineers instructed the AACS to use the correct computer, solving the issue. The next step is to determine what caused the system to switch in the first place. Although not a serious concern for Voyager 1's safety, identifying and correcting the fundamental cause is necessary to prevent future anomalies. In the vast expanse of interstellar space, Voyager 1 has been a true pioneer, journeying beyond the protective shield of our Sun's magnetic field for over a decade. Despite the hostile environment with high-energy particles and cosmic radiation bombarding the craft, Voyager 1 has continued to push forward, delivering valuable data and insights about the mysteries of deep space. According to Susan Dodd, the project manager for Voyager 1 and 2, strange occurrences like the recent AACS malfunction are expected in this groundbreaking mission. After 45 years of exploration, the Voyagers remain a testament to human ingenuity and determination. Let's hear your thoughts about the Voyager mission in the comments section below.